Now, if Earth's history were a movie, we humans would only take up the last second of the end credits. Our planet has been around for about 4.6 billion years, but our human story began about 300,000 years ago, in Africa. Now our ancestors had some wild adventures in nature. They could have run into creatures so big they'd make today's elephants look like puppies. The woolly mammoth is a pretty famous animal, sure. His cousin, though, the Columbian mammoth, not so much. This giant used to roam places from Canada all the way down to Mexico. Unlike the furrier woolly mammoths, which hung out in colder places, these animals had shorter hair, resembling huge elephants. They also had incredibly large tusks, like 12 feet worth of spiraling, sturdy tusks. And they weren't just for show, they came in handy when facing predators. That includes our ancestors. If you think about sloths these days, you're picturing these adorably slow creatures. They couldn't possibly be in your list of most dangerous animals. Well, their grandparents might have. For starters, we call them ground sloths, and they vary a lot in size. Some were as big as rhinos, and others, like the Megafauna, were as colossal as elephants. Imagine seeing a 20-foot-long sloth which doesn't mind chewing on some meat every now and then, at least in theory. Ever heard of Bigfoot? Well, our next animal kind of looks like him, but is a distant cousin to orangutans. Meet Gigantopithecus, the largest primate to ever call our planet its home. Standing tall at 10 feet and weighing more than 600 pounds, these animals were amazing to look at in real life. Unlike Bigfoot, they weren't constantly hiding. In fact, it's believed they were peaceful and gentle creatures. Sadly, they faded away about 100,000 years ago, mainly because their food sources slowly became unavailable. Those lush, fruity forests they called home eventually turned into dry grasslands. Next on our list is the cave hyena. Weighing a chunky 250 pounds and standing 3 feet tall, these beasts were as long as a grown-up lying down. What's even more interesting about these creatures is that they love hanging out in groups. A pack could be as big as 30 of these animals, which meant they could easily take on even the biggest, heaviest mastodons. Our ancient families would have needed to stay alert around these hungry specimens. Sadly for these hyenas, about 20,000 years ago, their numbers started going down. Soon enough, they completely disappeared from the planet. Quick pop quiz. What's called a tiger but isn't really one? It's the saber-toothed tiger. I mean, sure, they belong to the feline family, but they aren't technically tigers. First appearing around 42 million years ago, in July, I think, many of their kind were gone before we even showed up. However, early Americans might have bumped into a couple of specimens from this group. If that really happened, it would have been quite the encounter. Think of the biggest wild lion today or the hefty Siberian tiger. These big cats also had some incredible features hidden in their fur. They were good at sneaking around, hiding, and pouncing on mammoths bigger than themselves. Their bite wasn't that strong, but they could open their jaws wide, like twice as much as a lion. And although their teeth were a bit on the weak side, they had buff forearms to pin down their dinner, giving those big fangs a purpose. Not the kind of kitty you'd want to play with. Dire wolves made their debut about 250,000 years ago. They were like the gray wolves we know today, but a lot stronger. While wolves these days stretch out to about 6 feet and tip the scales at 170 pounds max, dire wolves were about 5 feet and about 150 pounds. Found all over North and South America, they had admirable jaws, biting nearly a third harder than their modern counterparts. Also, their favorite snack was horses. But just like many other majestic beasts of the past, they faded away around 10,000 years ago. Now, names can be deceiving. Take the American lion, for example. It's not really a lion, it's more of a panther's big cousin. The other part of the name is correct, though. They did live in America about 330,000 years ago. This feline was no lap cat either. They were at the top of the wildcat pyramid, weighing a colossal 772 pounds. That's like stacking 4 grown men on a scale. Even the mighty African lion would look a tad bit shy beside these beasts. With the muscle to take down a bison, you wouldn't want to accidentally interrupt their dinner. They parted ways with this planet around 11,000 years ago, right after the last ice age. Now down in Australia, about 50,000 years ago, I wasn't around then, there lurked a relative of the Komodo dragon, the Megafauna. Experts love to have debates on how big it was. Some say it stretched out to 23 feet. Others think it was just about 11 feet long. Either way, they were basically mega-sized Komodo dragons with a dangerous bite. If you think bears are already big and fluffy now, let's introduce the short-faced bear. While this big creature stood on its hind legs, it towered at 14 feet. With long limbs, they could outrun today's bears, hitting speeds up to 40 miles per hour. These ultra bears sadly disappeared around 11,600 years ago. Now imagine a crocodile. Okay, imagine that same crocodile, only supersized, with sporty legs, doing its thing in Australia about 1.6 million years ago. Well, say hello to the quincana. These crocs were extremely large, reaching 23 feet. And no, they weren't lazy river loungers. These creatures really love spending time on land. They evolved to have strong legs for their chases and razor-sharp teeth designed for slicing, not gripping. When did we stop sharing beaches with them? About 40,000 years ago. The name elephant bird might not sound familiar, but try to picture a bird that stood tall, as high as a basketball hoop at 10 feet, and weighed as much as a small car, 1,500 pounds. Their eggs were equally huge, like 150 chicken eggs bundled up into one. Now, as amazing as these birds sound, there's a lot we still don't know about them. They're hard to study, as most extinct animals are. Still, some recent studies have given us some clues. Scientists have been examining ancient molecules from their fossilized eggshells. It's an awesome piece of evidence, since these birdies' shells were thick, preserving precious DNA inside. Plus, there are tons of these eggshell fragments sprinkled all over Madagascar's beaches. Because of these findings, we now know these birds were herbivores and loved eating leaves and seeds. We also know the tiny kiwi bird is its closest living relative. Now, dodos were these amazing birds we also used to share the planet with. They're like distant cousins to Asian pigeons. To give you some perspective, imagine a chunky bird weighing about 50 pounds. Similar to chickens, turkeys, and ostriches, dodos were also the types of birds that couldn't fly. Their wings were small, and they had the muscle strength of, well, a wet noodle. Now, you might have heard the word dodo used as a name for creatures that aren't that bright. Don't get confused, though, by this name. These birds were in fact intelligent. Scientists were able to figure that out by studying their fossils. It turns out that they were good at smelling stuff, unlike most birds that are all about the visuals. These creatures aren't around for us to study anymore, but that might change. One evolutionary biologist is on a mission to fully understand these amazing ancient birds. On that note, she revealed that the dodo's DNA has been completely sequenced. There are even talks about potentially bringing dodos back to life. They would make a nice addition to the lovely beaches of Mauritius, the place they used to call home many, many years ago.
You're off to work, and boom, you see someone getting snatched by a 5-foot giant eagle that has the power to lift a child. Luckily, this is a pretty rare occurrence now, but around 2 million years ago, it was totally possible. Humans are now on the top of the food chain. I mean, many animals can hurt us, but they would rather munch on something less dangerous than people. Until a couple of years ago, almost everyone thought we were the #1 predator in the world since the beginning of our times. But let me tell you a little secret. We weren't the top predators. Somewhere in Africa, near the town of Tang, in a mine, archaeologists uncovered something probably worth more than gold. It was a small skull that belonged to a hominin, a human species that lived just before we split into two groups. One group is today's chimpanzees, and the other one is us humans. That is probably why we're so similar to chimpanzees. And believe it or not, we share 98% of our DNA with them. The critter was nicknamed Tongue Child because most likely it belonged to a young human. Before this discovery, we had no idea we originated from Africa. As you already know, on that continent, there were many big animals that could eat us in a single bite. Even now, the situation is not that different. The bone was found among many other animal bones, suggesting that early humans, Australopithecus, had a pretty rough life and were eaten by anything that liked meat. Since we were only around 4 feet tall, we were on the menu for many animals. Probably the scariest one for us was the eagle. You might think eagles are just lazy birds who sit on trees all day, but our friend from Tongue had a pretty bad experience of encountering one. When Tongue's child was a little kid and was playing outside, the eagle grabbed him and took it to its nest. We have no idea how big the bird was or what kind of eagle it was, since there isn't any evidence. Eagles regularly hunt baboons in Africa now, and when experts compared the marks on these animals with the marks found on the ancient skull, they discovered those marks were almost identical. The worst thing about eagles is that they're like zombies, and their favorite food is brains, so they attack the head first. Even now, we're not safe from sky attacks since eagles can theoretically snatch kids. Stop looking at the sky now. There are many more land animals that can harm you. Roughly 500,000 years ago, our ancestor, Homo rhodesiensis, was doing his chores when he was ambushed by a hungry ancient hyena. He had a few broken bones, and the hyenas stashed him in a cave in Casablanca, where he was uncovered 500,000 years later. Not many animals can chew through bones like it's nothing. Hyenas have a bite force that is 7 times stronger than ours. They keep meat stacked in hidden places, so they can have snacks for later. Since we can't see at night and hyenas can, they hunted us at night. This might be the reason why people are scared of the dark. It's an instinct passed down from our ancestors because, at night, they had to stay inside caves or other structures to avoid monsters. Technically, our ancestors played real-life Minecraft in survival mode, but our long-lost cousins weren't afraid of hyenas since they hunted them for food. Hyenas also hunted us for food, so what exactly happened will most likely remain a mystery until we invent a time machine. Today, hyenas are known man-eaters, but they're nowhere near their ancient ancestor, which was twice their size. Homo heidelbergensis was an incredible hunter that hunted everything from giant deer, rhinos, bison, and many more animals. But there was one creature that made the hair on their necks stand up. It was a giant with 8-inch teeth, weighing more than 1,000 pounds. No animal was safe during its era, which was around 300,000 years ago. Of course, I'm talking about the saber-toothed tiger. It actively attacked our ancestors, among other animals like crocodiles, monkeys, horses, and honey badgers. You might be one of those who have a terrible fear of snakes, and that might be because they hunted your ancestors. We have been sharing this planet with snakes for over 100 million years. Our early pals were so scared of them that they evolved and developed sharper eyesight. Their brains grew bigger since snakes were ambush hunters, sneaking up on humans and attacking them unexpectedly. Initially, we were colorblind, but snakes hunted us so much that we developed 3-dimensional vision and the ability to see colors. All of these tricks allowed us to see snakes better. But evolution works both ways, and around 60 million years ago, these reptiles developed venom because they lost the ability to stealth attack. The good news is that humans have developed bigger brains and learned to distinguish between venomous and harmless species. The worst monster Neanderthals probably had to watch out for was other Neanderthals. There's much evidence that shows that we sometimes were unfriendly towards each other. This theory is called the dangerous ape theory. Neanderthals didn't hunt one another regularly since there was an abundance of animals that had more nutrients needed to survive. Neanderthals most likely hunted one another when they didn't have any other food, or for rituals, or in self-defense. Around 4 million years ago, near Lake Turkana in Kenya, there was a humongous crocodile with a taste for humans. It was not that modern-day croc that can only reach 20 feet in length. Its ancient relative was 27 feet long, the largest crocodile ever. This prehistoric creature could swallow us in one bite, since we were only 4 feet tall back then. We don't have proof that this animal hunted us, since they had a powerful stomach that could liquefy bones easily. But there was a foot found that had clear marks from a crocodile's jaw. The ape probably wanted to cool off or drink some water and was grabbed by the prehistoric reptile. Crocodylus anthropophagus is another croc species that lived near Tanzania around 1.8 million years ago and ate humans like burgers. It loved people so much that its Latin name literally means the eater of humans. They patiently waited underwater for humans to come for a drink, and when they arrived, the monsters would snatch and drag them underwater. Evolution was trying to find solutions because we encountered scary monsters and were hunted by them. All that running from predators had an impact on our bodies. We grew taller and bigger so that birds wouldn't pick us up and fly us to their nest. Like it or not, we had to start walking on two legs since we could scan the surroundings much better that way. It helped us to run from predators while carrying food. Plus, standing up made us look bigger. Now we throw things with our hands for fun. For example, while playing basketball. But back then, we had to throw rocks at predators to make it out alive. Chimpanzees also used this throwing technique to scare off predators. We started talking to each other to coordinate attacks better and plan what to do when we saw danger. We all know that working in a group or playing a team sport is interesting and a lot of fun. But believe it or not, this is because in the past, we had to be team players. Otherwise, we risked being snagged by a predator. Our brains are still wired the same. However, these techniques didn't always work, and archaeologists have found many more bones belonging to humans eaten by giant eagles and other animals. Bam! The giant asteroid slammed into Earth, and a while after that, dinosaurs were gone. You'd think there's nothing to be afraid of now, but nope, some pretty unique and scary beasts started to evolve after that. Back at that time, mammals were going through significant changes. It seems that some of them, like those similar to horses and rhinos, became giant and powerful very soon after the dinosaurs were gone. When dinosaurs were in charge, which was about 145 to 66 million years ago, mammals were relatively small creatures. Most of the time, they lived in the shadows of their much bigger enemies to avoid ending up as their dinner. Many of them weighed around 22 pounds or even less. But when the dinosaurs went extinct, mammals finally had a chance to take advantage of the new environment. For example, Brontosaurus. It took this opportunity and grew to enormous sizes. They started at around 40 pounds and eventually reached weights of 4 to 5 tons in just 16 million years. This sounds long, but it's relatively short in geological terms. Their large body size gave them and some other mammals an advantage after the dinosaurs disappeared. Now, they were the dominant and ferocious creatures others were afraid of. Brontosaurus, whose fossils have been found in North America, got this cool name, Thunder Beasts, from the Sioux people, because they believed these fossils came from giant thunder horses that would roam the plains during thunderstorms. And it's still a mystery how these thunder beasts got to grow so big so quickly. One of the theories says that they gradually increased in size over time. Another option is they went through rapid bursts of growth, but also had periods where they didn't quite change. Or maybe there was a mix of species. Some were small and some were bigger, but in general, more of them ended up growing large. And scientists studied a family tree of 276 thunder beasts and realized the third option fits the best. It's all competition in nature. Back in that time, most mammals were small, so there was fierce competition among smaller plant-eating animals when it came to food. The larger ones, like thunder beasts, faced less competition for the resources they needed to survive, so bigger species had more chances to stay, while the smaller ones went extinct quickly. So yeah, the end of the dinosaur era doesn't mean the end of impressive and giant animals you'd also run away from. For example, I definitely wouldn't like to face this fella. It kinda reminds me of a giant sloth at first, but those evolved tens of millions of years later. This giant lived somewhere between 50 and 60 million years ago in North America. It was around 8 feet long and had an unusually massive and thick body and legs. Its tail was very thick as well. This beast must have used it to support itself and stand on its hind legs. Its skull was relatively short and small compared to its large body. What's interesting is that it still had collarbones, which are bones that most hooved animals don't have anymore. Here's something comforting that makes it less scary though. They probably ate plants that were soft enough to chew easily. Now, imagine a snake so big it could easily rival the size of a T-Rex. It's not some mythical creature from fiction movies, but Titanoboa, the incredible beast that lived around 60 million years ago in the lush forests and rivers of South America. It was the largest snake ever that we know about. It was actually like the ancient ancestor of today's boas and anacondas that still live in the same region. Its body was a mind-boggling 42.7 feet long, which is longer than a school bus. To support its giant body, Titanoboa had about 250 vertebrae, which are the bones that make up the backbone of animals. Imagine how much it needed to eat to maintain such a massive body that was as heavy as a small car. It went after fish and crocodiles that lived in the waters and rivers of its home. A snake taking down a crocodile? It had to be a powerful beast. Titanoboa holds the record at the moment, but scientists believe we might discover more fossils of snakes that could be even bigger than this one. You know there has to be some scary crocodile on the list. Back in the dino era, there were even crocodiles that were 40 feet long and enjoyed snacking on dinosaurs. You can tell they haven't become less scary even after that. This beast lived between 15 million and 55 million years ago in what is now Venezuela, Peru, and Argentina. It belonged to a group that was there during the time of the dinosaurs, but like many others, got to live their best years and thrived after the dinos disappeared. Unlike most crocodiles that stick to the edge of the water, you could easily come across this one, since it liked to take walks on the land to check what was happening around. Check out its flattened blade-like teeth. They remind of those carnivorous dinosaurs even more than other crocodiles. This adaptation helped with catching prey during its chill afternoon walks on land. This fearsome creature could grow to over 20 feet long and weigh more than 3,000 pounds, which is bigger than today's saltwater crocodiles. Even a rhinoceros came in the XXL size in those post-dino times. This one, whose name I can't even try to pronounce, was a massive herbivore that lived in eastern Eurasia. It looked like a rhino, but it still had some differences, like its neck that was stretching over 6 feet long, which made it look like a rhino with a giraffe's neck. The creature stood more than 15 feet tall at the shoulder, towering over most other animals of its time. It looks slender, but it's still incredibly heavy with its 33,000 pounds, which is like 2 to 3 grown African elephants, or even a small house. One of the biggest carnivores that wandered Ice Age Australia wasn't a mammal, but this frightening reptile called Megafauna. It could grow to be over 18 feet long, which is more than twice longer than the Komodo dragon, one of the largest lizards alive today. Megafauna had sharp curved teeth similar to those of Komodo dragons, which means its bite was extremely powerful and maybe even venomous. This venom worked in a way it could have prevented its prey from healing property, which means the poor animal would become weaker, so Megafauna didn't even have to work that much to catch it after that first bite, no matter where its prey would try to escape. Moving on to birds now. An elephant bird stood almost 10 feet tall and weighed over 1,000 pounds. You could see it on the island of Madagascar more than 1,000 years ago, which is not even that long ago compared to the others. One of the multiple species of elephant bird was so big that it could rival some non-avian dinosaurs, such as Utahraptor when it came to size. And its eggs were gigantic too. Just one egg could weigh more than 20 pounds, which is heavier than a bowling ball. The interior of its egg had a lot of space, So much, you could hold more than 100 chicken eggs inside. Land and air weren't safe from big beasts where you couldn't be sure if it wanted to eat you or your salad. And it was not much different in the water either. You've heard of Leviathan, right? It was an ancient, powerful predator and a type of sperm whale, but much larger and more fearsome than those we know today. While modern sperm whales mostly eat squid, Leviathan probably had a little bit different diet, which included other whales. Another giant predator was also roaming around the same time and place as Leviathan. Who else but our dear Megalodon shark? Scientists believed Megalodon also went after other whales, and the fight for the sweetest bite, or even among each other, was probably spectacular.
Now this bad boy was the size of a husky and could maybe pass for one, except it didn't have any fur and was a top predator with extra long blade-like canine teeth. Ooh, charming. Meet the earliest known saber-toothed animal to have ever lived. It roamed the earth well before the dinosaurs. Scientists made the description of this creature based on its fossils found on the Spanish island of Majorca in the Mediterranean Sea. About 200 million years ago, none of us were around then, the very first true mammals appeared, and they lived right alongside the dinosaurs. But if we trace the family tree of mammals even further back, we'll find an ancient group called theropsids. They didn't look like mammals we have today, but they had some key features that would eventually help define mammals. For example, theropsids had special openings on the sides of their skulls for jaw muscles, and parts of their jaw bones would later evolve into the tiny middle ear bones that all mammals, including you, have today. So, the new discovery is what might be the oldest known theropsid fossil. The fossil, which doesn't have an official species name yet, belongs to a group called Gorgonopsians. Those guys are more closely related to mammals than they are to any other living animals. Some of them were as small as cats, and others were as massive as polar bears. Gorgonopsians had some very mammal-like traits, like different types of teeth for different jobs. But unlike mammals, these ancient predators kept replacing their teeth, even their giant saber-like canines, over and over during their lives. Hey, that would be handy. Until now, the oldest Gorgonopsian fossils we knew about were around 265 million years old. But this new fossil is even older, dating back between 270 and 280 million years. The find was super detailed and complete, including its sharp knife-like fangs, part of its jaw, pieces of its spine, ribs, tailbones, and toe bones, plus most of one of its back legs. Even though the creature's skull wasn't complete, the scientists think it was about 7 inches long, and the animal itself would have been around the size of a medium-large dog, weighing between 66 and 88 pounds. But other than that, it didn't really look much like a dog. Even though it had some lizard-like features, calling it a lizard dog is totally wrong. Mammals and reptiles do share a super ancient ancestor from about 320 million years ago, but their evolutionary paths split a long time ago. When the newly found creature was alive, the island of Majorca was right in the middle of the gigantic supercontinent Pangaea. Back then, this area went through super wet and super dry seasons. Scientists have always wondered if major moments in mammal history happened in tropical places like this, but we just didn't have the right fossils to prove it. Now, with the discovery of the oldest known Gorgonopsian in Majorca, the missing pieces of the puzzle are coming together. It looks like some huge steps in mammal evolution could have happened in low-latitude environments we haven't explored much yet. The so-called gap in the fossil record might just be because paleontologists weren't looking in the right spots. Our hero of the day wasn't the only cool guy rocking the planet before dinos settled in. Over 500 million years ago, the weirdest predators to have ever existed ruled the oceans. The name is a bit tricky to pronounce, so I'm not going to. Okay, it's Anomalocaris, but it just literally means unusual shrimp. This creature looked nothing like anything alive today. Scientists think it was the first true apex predator, the orca of its time. Anomalocaris was massive for its era, as it grew up to 3 feet from its sharp grabbing arms to the tips of its tail fins. For a while, everyone thought trilobites were its go-to meal, but new research shows it wasn't strong enough to crack open trilobite armor. So instead, it was a speedy, agile hunter with awesome vision, and it often picked off soft-body animals that zipped through the open water. Now, another really cool creature from pre-dino times is a fish that could walk on land. Tiktaalik lived in marshy rivers that looked a lot like today's Amazon rainforest. It could grow up to 9 feet long, and it found its prey in rivers and inlets like a modern-day freshwater crocodile. It had a flexible neck and even some early versions of lungs, and thanks to them, it could survive both in water and out of it. Why fish like Tiktaalik started moving toward land about 395 million years ago is still a bit of a mystery. Around that time, the ancient supercontinent called Gondwana was drifting closer to the land that would become North America. This slow movement created lots of shallow, swampy habitats, which were perfect places for crocodile-like animals to thrive. Plus, these areas were near the equator, so they were warm and tropical. But there wasn't a lot of food waiting for them on land, so maybe they moved there for safety reasons. There were fewer predators and better spots to lay eggs there compared to the water. Creatures first adapted to living in open water, then shallow water, then marshes and river edges, and only after a long, slow transition did they finally step fully onto land. Now, how about a millipede the size of a small car and weighing as much as a large dog? This beauty lived over 300 million years ago in what is now England. Back then, during the Carboniferous period, Earth's atmosphere had way more oxygen, over 26%, compared to today's 21%. Scientists used to think the high oxygen levels were the only reason these creatures could get so big. But back then, they found a new fossil from a time when oxygen wasn't that much higher than today. They discovered it purely by accident when a boulder split just right and revealed one of the most complete and largest giant millipede specimens ever. This one could have lived not just in swampy areas, but also in open woodlands filled with tasty seeds, nuts, and maybe even small animals. There's a chance that this beast wasn't a slow, plant-munching crawler, but a predator that would snap up whatever it could find. After dominating the Earth for about 45 million years, the giant millipedes eventually vanished. Probably the reptiles pushed them out, clearing the way for the age of the dinosaurs. Now, in case you ever wondered what would happen if you crossed a polar bear with a saber-toothed cat, here's the answer. This guy ruled the southern ecosystems after migrating 7,000 miles across the supercontinent Pangaea around 252 million years ago. It had a tough skin like a rhino's and massive canines, perfect for tearing away huge chunks of meat, and it was an excellent runner. Once it got to its new home in what is now South Africa, it replaced a whole group of local predators. But its glory didn't last long, as closer to the end of the Permian period, massive volcanic eruptions made the weather patterns change and wiped out about 90% of all species. And because top predators are usually big, slow to grow, and not super common, they often vanish among the first when massive extinction events hit. And that's how our guy here went extinct. Our final creature of the day was a dragonfly that lived around 300 million years ago and had a wingspan of over 2 feet, 6 long, spiny legs, and huge, bulging eyes, Megafauna. This 4-winged giant is most likely the largest flying insect that ever lived, and it easily outsizes today's dragonflies, which are its distant relatives. Like modern dragonflies, Megafauna like to hang out in open areas near ponds and slow-moving streams. But unlike today's dragonflies, it wasn't just catching tiny bugs. This guy was likely the top predator in these open spaces. It used the spines on its legs like a flying trap to snatch prey out of the air, including other flying insects, small amphibians, and even lizard-like creatures. Scientists found the first fossils of Megafauna in 1880 in the coal-rich rocks in France. The fossils were incredibly well preserved and showed off the detailed vein patterns in their wings. Scientists think Megafauna grew so huge because it didn't have much competition from vertebrates, and the air back then, during the Carboniferous period, had a lot more oxygen than it does today. Australia used to have its own giants. Those were huge animals that could have dwarfed anything living on this continent these days. Scientists found the remains of many of those ancient creatures in the Narracuta Caves in South Australia, 4 hours away from Adelaide. It's a lovely region, but it can be treacherous. Watch out for holes the ground is pocked with. Known as pitfall traps, many of them are no wider than a coffee table. They're deep and plunge into the darkest of caverns. One of such caverns is called Victoria Fossil Cave, and it's a treasury that's been hiding the bones of around 45,000 animals for centuries. Some of the oldest bones belong to creatures far more terrifying than any animal you can encounter today. Those were the ancient Australian Megafauna, huge beasts that roamed the continent during the Pleistocene epoch. During those, there were giant snakes, huge flightless birds, wombat-like creatures the size of a rhinoceros, and many others. One of the largest examples of the Australian megafauna scientists have discovered so far is the Diprotodon. That giant herbivorous creature was 10 feet long and 6.5 feet tall, and weighed more than 6,000 pounds, about as much as a small Asian elephant. Even though this terrifying beast didn't eat meat, it could have smashed other animals with its sheer weight. Scientists have found the remains of hundreds of such creatures all over Australia, so it's safe to say that no other animal from that time or in that location was larger than this giant. Despite its creepy appearance, the Diprotodon was a relative to the modern-day wombat, and those are known to sometimes pounce humans. The Diprotodon had toes that pointed inward and were well suited for digging burrows. On the other hand, Diprotodon was a giant, and it was unlikely that it used to do so. It was likely a trait it had inherited from its smaller burrowing ancestors, or it could have used its claws to search for roots. This theory is supported by the fact that the animal's pouch was facing backward. It prevented any dirt from collecting inside while the creature was digging. Since this animal was so big, it didn't have to worry much about predators. Up until 60,000 years ago, when the first humans appeared on the continent, full-grown Diprotodons only had to look out for creatures like the quincana. Measuring in at a whopping 20 feet long, the quincana was a land crocodile. It lived in Australia from around 20 million to 40,000 years ago. It disappeared along with most other mega creatures of the last ice age. It's thought to be the result of the first humans coming to the continent. Even though the quincana was extremely fast and dangerous, it was possible that this creature got outcompeted by human hunters who took all available prey. Unlike modern crocodiles that are mainly aquatic, that mighty beast was a land dweller. Scientists figured it out by studying the quincana's legs. They were able to support and carry the body clear off the ground. It means there was no escape for ancient people once the quincana spotted them. Modern crocodiles can only push themselves along on their bellies. Such an adaptation allowed the quincana to chase its prey for long periods of time, exhausting it in the process. Another creepy feature of this ancient monster was its teeth. Aquatic crocs have conical teeth. Those are great for gripping and holding on to prey underwater. But quincana had knife-like teeth, ideal for slicing soft-bodied animals like mammals. Another Australian monster, Thylacoleo, wasn't all that large, but it didn't make it any less terrifying. It was still among the top predators and the biggest carnivorous animals in Australia. This creature was a true oddity of nature, even by prehistoric standards. First, its teeth resembled not those of a regular predator, but those of a rodent. Its front incisors were enlarged, taking the place of canines. Premolars were also shaped like blades. They were used for cutting flesh and bone. At first, scientists thought that Thylacoleo used those teeth to eat nuts and fruits. But later, a study showed that the use of such teeth was better suited on necks and spines. The jaws of this ancient creature were immensely powerful. A 220-pound Thylacoleo had a bite force similar to that of a present-day 550-pound lion. It means that the animal could easily bring down prey much larger than itself. Then there was Thylacoleo's tail. It had strong muscles which provided the animal with the ability to use the tail as support when tackling large prey. The Thyakoleo had retractable claws, and this feature is very uncommon among marsupials. It allowed the animal to keep its razor-sharp hooks from getting blunt and could help it get a better grip on its prey. Scientists are quite sure that, like today's leopards, the Thyakoleo could climb trees and jump on other animals from above. It was done so fast and stealthily, they never knew what hit them. The creature's rear feet support this theory. The first toe there was reduced, but the foot had a rough pad like what modern-day possums have. It allowed them to have a better grip while climbing. Right after scientists found the first skull of the Meliolania, this animal was classified as a lizard. That's why its name translates to small groomer. But after they discovered more complete fossils, it turned out that the Meliolania was a giant turtle. But that's not all. It was one of the largest land turtles to ever have existed. The main reason researchers initially believed the creature to be a lizard was the fact that its skull was adorned with a series of spikes. It's something the modern-day horned lizard can boast. But even after discovering the true nature of the Meliolania, scientists still don't know how to properly catalog it. It might have been a creature that folded its neck under its spine, or it could have folded it to the side. Beside those defensive mechanisms on its head, the Meliolania was also equipped with a spiked tail, which was probably used to prevent predators from attacking the animal from behind. Most species of the Meliolania disappeared around 2,000 to 3,000 years ago because of humans who hunted them to extinction in both Australia and on the surrounding islands. It took around 2 centuries for these turtles to go extinct in that region of the globe. The Megalania was a giant Australian lizard that existed at the end of the Pleistocene epoch. It looked like a Komodo dragon and the Australian monitor lizard, which are both believed to be Megalania's closest living relatives. Fossils tell us that the ancient animal was anywhere from 15 to 26 feet in length. Ow! The youngest fossil remains of this ancient Australian monitor lizard date back to about 50,000 years ago. The first indigenous settlers must have encountered Megalania, which led to the lizard's extinction. Originally, scientists thought that the Megalania was the only member of the genus Megalania, but these days it belongs to the genus Varanus, which means that the prehistoric creature is closely related to other Australian monitor lizards. Our next giant creature on our list was once dubbed an ostrich on steroids. I mean, look at it. It was the last of the thunderbirds to go extinct in Australia. The Genyornis lived on the continent at the same time as early humans. They might have coexisted for 15,000 years or so before the huge bird eventually disappeared. This theory has some proof. The bird's fossils found along with human artifacts. Some cave paintings also depict flightless birds similar to the Genyornis in size and shape. Although it wasn't the largest bird in Australia, the goose-like creature was still as tall as a grown-up man and weighed around 550 pounds. Even a modern-day ostrich can be dangerous if it feels threatened. Imagine meeting its giant prehistoric relative. Scientists are still arguing about its diet. Many believe the creature was an herbivore, but there's still a chance that the Genyornis was a partial scavenger. Its small, stubby wings and powerful hoof-like legs hint that the bird could have been a plant eater. But its huge beak and exceptionally deep lower jaw evoke suspicion. Such features are highly unusual in birds. Well, a biotech company called Colossal just announced something wild. They say they've brought back a direwolf from extinction. But did they really? What they've really done is way stranger, and maybe even more important. Their team has just created a brand new predator. Not a clone, not a revival, but a new species. These cute cubs are built from gene-edited wolves, shaped by ancient DNA and born through cutting-edge biotech. So wait, are the Jurassic Park horrors coming for us? Well, let's see. Now, direwolf was the massive muscular predator that roamed North America thousands of years ago. Most people think these were just some sort of bigger gray wolves, but don't be tricked by appearances and the name. In 2021, a landmark study came out. A team of researchers in major institutions studied actual direwolf DNA and discovered something shocking. These guys weren't just big gray wolves, not even close. They were separate animals. Genetically, direwolves split off from wolves roughly 6 million years ago. Just to put that in perspective, humans and chimps split about 6 to 7 million years ago. So dire wolves and gray wolves are as different from each other as we are from chimpanzees. They look similar because of the so-called convergent evolution, when two species evolve similar traits because they live in similar environments. Think of sharks and dolphins, both streamlined, both predators, both ocean hunters, but different animals, and dolphins are way cuter. So Colossal said that they revived this animal, a dramatic and bold claim. But it's not quite true. In reality, they genetically engineered a new kind of wolf. It's not a dire wolf, it's not even a known species. It's a synthetic animal, one that's never existed before. And this is a massive deal, both incredible and terrifying. The company basically has taken gray wolves and modified their genes by mixing them up with some dire wolf DNA they found. Which is kind of wild, because, as we said, these two animals aren't really relatives, they're completely different species. The Colossal company kind of ignored that, though. They say the gray wolf is the closest living relative to a dire wolf, and that the data proves it. But what data? They haven't shown it so far, it's just a claim. Why are they even calling this a dire wolf? Well, they're saying their cubs are close enough to a dire wolf and maybe fill the same role in an ecosystem. Basically, if it behaves like a dire wolf, walks like a dire wolf, and preys like a dire wolf, doesn't that count? Sounds kinda dire to me. Well, if we're being honest with words, then not really. Biologically, genetically, evolutionarily, this is now a modified gray wolf. So, how good or bad is it? Let's figure it out. The good part is that the research like this might help us restore the planet's ecosystem and ecology. Colossal and similar teams are trying to develop technologies that could be used for especially important causes. We don't notice it in daily life, but species are quietly, constantly disappearing. Scientists estimate that over 1 million species are at risk right now. When ecosystems lose a species, especially because of humanity's actions, it's like pulling out a block of a Jenga tower. Too many missing blocks, and the whole thing wobbles. But Colossal believes that if we can't bring the exact block back, we can create one that fits closely enough to stabilize the structure. For example, they've also worked on cloning red wolf-coyote hybrids. This might help repopulate U.S. ecosystems where red wolves once thrived. All the tools these scientists invented might even help with currently endangered species. Another genuinely mind-blowing part is that scientists working with Colossal found real, usable DNA from dire wolves. That alone is a massive achievement. We do have dire wolf fossils, tons of them from the La Brea tar pits. Hey, don't stick your toe in there. But those fossils are soaked in tar. Because of that, their DNA is usually ruined. But the team managed to find some dire wolf bones that are over 12,000 years old. These specimens gave researchers enough material to begin building a dire wolf genome. Not a full one, but a basic blueprint. Even if we ignore the wild new species part, this achievement is still huge because it'll help us study the extinct dire wolves in more detail. We might now learn more about this animal than we ever did before. It's literally molecular archaeology. Now, all this is great, up to a point. The controversial part is, of course, the Jurassic Park one. We're not just preserving species anymore. We're starting to pull some shenanigans with them. Of course, this immediately raised tons of concerns. Both regular people and scientists are now debating heavily about this and show a lot of skepticism. Another problem is that actual ecosystems are way more complex than Jenga puzzle pieces. They're full of moving parts, millions of them, all adjusting to each other constantly. So, if you throw a new type of wolf into the mix, it won't react exactly the way a dire wolf once did. The times have changed, the ecosystem has changed, the extinction happened, nature adjusted, and throwing these cubs into the wild now might be even more destabilizing. That's why these new wolves aren't being released into the wild. They won't be hunting bison or roaming ancient grasslands. That world is long gone. Their prey is gone. Their ecosystem is gone. Instead, they'll stay to live in the lab. But if we do start to put our own animals into the ecosystem one day, what happens when ecosystems start depending on human-made species to survive? Well, it's like I always say, it's nearly impossible to science your way out of a situation that you behaved yourself into. If you can't change the behavior, the science might only be flashy and not the solution. Anyway, all these are hard and important questions. For now, we might at least exhale with relief that no one is bringing the dinosaurs back. Yeah. DNA doesn't survive more than 1.5 million years, and dinosaur fossils are stone now, not cells. You can't clone from stone. But what about animals that vanished more recently? Creatures that once lived during the Ice Age, or even just a century ago? Those are within reach. The most famous example is the woolly mammoth. These shaggy giants once stomped across the tundras of the north, shaping nature by knocking down trees, flattening snow, and fertilizing soil. Their disappearance helped turn thriving grasslands into mossy, carbon-trapping bogs. Now scientists want to take preserved mammoth DNA from frozen remains, compare it with elephant DNA, identify the key differences, and create a new hybrid. Kind of the same thing we did with these new dire wolf cubs. It would be a cold-resistant, tundra-stomping, woolly-coated mammoth elephant. Like that. These guys would be close enough to fill the ecological niche that mammoths once held. Then there's also the passenger pigeon. Once the most abundant bird in North America, flocks so massive they could block out the sun, but we hunted them to extinction by the early 1900s. The last one, named Martha, passed away in a zoo in 1914. But we have her DNA preserved in museum samples. And today, using AI and genomics, scientists are working to recreate a living bird that behaves like a passenger pigeon. These birds could help regenerate forests, spread seeds, and restore a part of the lost sky. And finally, the Tasmanian tiger, a striped wolf-like marsupial that once roamed Australia. It was hunted to extinction in the 20th century. But its DNA is abundant. Museums collected pelts, fossils, and even preserved pups. This one was a keystone species, a stabilizer, a hunter that helped keep ecosystems in check. So they want to restore this one as well. The idea is to bring back extinct species using artificial intelligence, genetic sequencing, and the rapidly growing toolbox of biotech. But all this has to be done very carefully. Otherwise, the species could destabilize the environment instead of helping it. Now, on the good side, even if we never bring a mammoth back, this research is already saving lives. For example, the northern white rhino. There are only 5 left, and only 1 male among them. Extinction is practically written into their future. But using preserved cells and cloning techniques, scientists are working on rebuilding the population. In any case, it looks like we're entering a new era of biology, and this discovery is going to start a conversation that will be going on for decades.
The Tyrannosaurus rex, the formidable predator, the world-known celebrity of the animal kingdom, the king of all dinos. Since its discovery in 1902, this dangerous predator has fascinated both researchers and the regular public. But despite its terrifying reputation, there were actually other beasts that could defeat the T-Rex. And one of the true nemeses of this dinosaur was the Triceratops, a herbivore. But despite its plant-based diet, the dino was huge and had 2 nightmarish, large horns and a smaller one, along with thickened bones which added to its defenses and helped protect itself from dreadful predators like the T-Rex. This dino was something like proof that herbivores were no pushovers. Its formidable horns were about a foot wide at their base and tapered into mean points capable of skewering any predator, even a T-Rex like Juicy Barbecue. The colossal skull of the Triceratops sported an enormous frill made of protective solid bone, which was topped with hornlets. From the tip of the animal's beak to the spiked rim of the frill, the head of the Triceratops could reach a whopping 10 feet in length and weigh around a ton. This gargantuan construction, the head of the dino, was attached to the body with the help of a ball and socket joint. This allowed the dino to swivel its head around with astonishing speed, brandishing its horns to scare predators away. That's one of the reasons why a T-Rex that decided to attack a Triceratops was actually taking a big risk. The battle could easily go either way. Of course, the king of the dinosaur world could win and get its long-awaited feast. But just as likely, the hunted could become the hunter and end the T-Rex's game. Now, how about we find some more cool and lesser-known facts about those intriguing creatures, dinosaurs? For example, dinos almost certainly did not roar. Scientists think they might have cooed instead. More accurately, they probably produced sounds in ways similar to the way ostriches boom or doves coo. You see, many modern birds use a method of producing sounds called closed-mouth vocalization. Sounds are made by inflating the throat rather than passing air through the syrinx, the vocal organ of birds. In other words, the Jurassic Park movies got it all wrong. A lot of early dino reconstructions appeared under the influence of those scary noises that we associate with modern predators, like lions. So, on screen, dinosaurs have their mouths open when they produce sounds, just like lions when they roar. But real dinos wouldn't have done that, especially not before charging at their prey. They wouldn't have advertised their presence to other animals nearby, not when all they wanted was to have a meal. The Quetzalcoatlus was a member of the ancient group of flying reptiles, pterosaurs, and it was also the largest flying animal to have ever lived on Earth. The giraffe-sized creature had thin limbs, a startlingly long beak, and a staggering 40-foot wingspan. Researchers believe that these creatures could have also used their folded-up wings as legs, so they probably walked on all fours. Scientists discovered the Quetzalcoatlus about 50 years ago, but they still have a tricky time trying to piece together the details of this animal's life. For example, how did it even manage to lift its ginormous body off the ground when flying? Whatever the answer is, this creature is our first real look at the entirety of the largest animals ever to fly. One of the reasons why it's been taking so long to unearth the secrets of the Quetzalcoatlus is because this creature had hollow bones that helped it to fly, just like modern flying animals. So, when you find these potato chips-like bones preserved in super hard rock, you need to somehow remove them without destroying them. And that's a really tough task. The Tyrannosaurus rex was quite a slow runner. Its speed was likely to be just about 10 miles per hour, which is approximately as fast as the speed of an average human runner. As for T-Rex babies, according to hatchling recreations from the American Museum of Natural History, they were pretty cute. About the size of super skinny turkeys and covered with downy feathers. The largest land-based dino was the Argentinosaurus. This massive animal often reached up to 130 feet in length and 69 feet in height. Considering the average blue whale is around 70 feet long, you can easily imagine just how giant that dinosaur was. Many dinos had feathers, and I'm not only talking about avian ones. The largest feathered dinosaur we know about was the Eutyrannus huali, which translates as a beautiful feathered tyrant. It was a super predator and cousin of the T-Rex. Scientists think that the dino most likely relied on its feathers to stay warm. However surprising it may sound, some of the biggest dinosaurs were actually herbivores. Let's take the Brachiosaurus and Apatosaurus, for example. These creatures were giant, but followed a plant-based diet. Now, I'm not sure if you should try it or not, but apparently, you can tell the difference between a simple stone and a dinosaur fossil by licking it. It may not sound like the most legitimate approach, but even paleontologists sometimes find themselves doing this. The thing is, if you lick a potential fossil, it will slightly stick to your tongue. That's because fossils are way more porous than stones. When dinosaurs first saw the light of day during the Triassic period, around 230 million years ago, Earth's continents were clustered together and formed one giant supercontinent called Pangaea. Over the next 165 million years, Pangaea slowly drifted apart, and that separated many dinosaur species from one another. And still, most of the world's dinosaur fossils are found in 3 places: the high-altitude Badlands of China, North America, and Argentina have the largest amount of fossils, or at least easily accessible ones. In reality, most parts of the world are covered with fossils, but those located in desert-like environments are easier to find due to the lack of vegetation. Interestingly, most fossilized dino bones aren't bones anymore. The fossilization process often occurs when something gets trapped between layers of sediment or sand. For millions of years, those remnants stay there. At one point, they got surrounded by a layer of water. It replaces the original organic material with minerals. In other words, it's not the real thing anymore. It's a rock-like copy. The Triceratops boasted 3 giant horns sticking out of its head, but its teeth were even more fascinating. This dino had around 800 teeth, and new ones kept growing throughout its life. These teeth grew in sets of 36 to 40 tooth columns, with each column having 3 to 5 teeth, vertically stacked on one another. Some dinos had hollow bones, like today's birds. These creatures stored air in their bones, which helped them improve their breathing abilities. It made these dinosaurs lighter on their feet and allowed them to breathe much more efficiently. The Nigersaurus replaced its teeth every 2 weeks. This unique creature had rows and rows of teeth in reserve. They were hidden away in its mouth, and when a set of teeth wore out, they fell out, and the next row moved into position. Dinosaurs didn't all go extinct at the same time as soon as the asteroid crashed into Earth. Instead, the space rock likely triggered a chain reaction of events which changed the face of the planet. Of course, it didn't happen overnight, but over the next few hundred or even thousands of years. As a result, all but avian dinosaurs went extinct. The word dinosaur came from the Greek language. Deinos means terrible, and sauros means lizard. So basically, dinosaur can be translated to terrible lizard. You may object that not all dinosaurs were terrifying predators. This name might be appropriate for the T-Rex, but not, let's say, the tiny May. Rumor has it that when Sir Richard Owen, an English biologist, came up with the name for dinosaurs, he used the word terrible in a different sense. He described those ancient creatures as fearfully great, as in far larger in size than any previously discovered reptiles.
Ooh, from giant spiders to venomous snakes, we all get freaked out by Australian creatures. Yeah, me too. But newly discovered fossils show that things were way more dangerous 120 million years ago, when this land was completely ruled by massive razor-clawed megaraptors. Yeah, I'm glad I wasn't around then. These dinosaurs were about 26 feet long and walked on 2 legs, just like the famous T-Rex. They were fast, fierce hunters, with a superpower: their hug. Yep, their massive, muscular forearms had huge curved claws, perfect for grabbing and holding onto prey. Uh-oh. They would wrap their arms around their poor victims, just like a hug, and trap them with no chance of escape. And even though their teeth were quite small, they were still sharp enough to rip through flesh. The first time we heard about megaraptors was in the late 90s, when a paleontologist discovered their fossils in the region of Patagonia, Argentina. Since then, no one has ever found a complete skeleton, only fragments. But probably the most important one yet was uncovered in Australia at the beginning of this year. Researchers were exploring Victoria's stunning coastline when they stumbled upon megaraptor fossils. First, they spotted bones from its lower legs and a few vertebrae washed up on the beach. Even though they were working with just a couple of fragments, a deeper analysis confirmed that these belonged to a megaraptor. And not just any megaraptor, it was the oldest one ever discovered. This discovery gets even more exciting because it adds weight to the theory that these dinosaurs might have originated in Australia. But we already knew that they roamed the land down under since early 2023, when researchers found the top of a megaraptor skull in the country. So let's rewind a bit. We first found their remains in Argentina, right? Right. But then, years later, researchers found fossils of the same family of dinosaurs on the other side of the world, in Australia. If the ones in Oceania were older, how did these creatures end up in South America? Of course, they didn't fly there. They didn't cross continents by swimming either, although there is a theory that they could swim. Remember, we're talking about the dinosaur era, which happened millions of years ago. And back then, Australia and Argentina were actually pretty close. Basically, they were one. Both lands were part of the supercontinent known as Gondwana, and they were connected through Antarctica. Wait, but wasn't this path freezing? I mean, yeah, these dinos had to pass through Antarctica to get to their destination, but they weren't freezing their tails off. This all happened during the mid-Cretaceous period, when the weather was super warm. Back then, the poles were covered in plants, not ice. So let's just say they took full advantage of the good weather to make the crossing. Now, about 180 million years ago, Gondwana started to break apart. At some point, Australia drifted away from the supercontinent, cutting it off from other landmasses, including South America. That's why the same dinosaurs showed up in completely different parts of the world. Mystery solved. Now, let's get back to that recent discovery. The researchers didn't just find a few traces of megaraptors on the beach. In total, they uncovered 250 dinosaur bones at the site, but only 5 of them were really important. They belonged to 3 different species of dinosaurs that, as it turns out, all lived in Victoria at the same time. So yeah, we've already talked about those first 2 bones. They were from the Megaraptor. Next, we have a shin bone from a Onenlagiine. That's my best shot at pronouncing it. It's a dino also known as the southern raptor. This is a type of dromaeosaur with a long snout. And the last 2 shin bones of different sizes came from a Carcharodontosaurus, whose name means shark-toothed lizard. This one is a particularly big deal for 2 reasons. Number 1, it's the first evidence that this species lived in Australia. And number 2, it was small, and that is pretty surprising since we've always thought of this species as being massive. Fossils found in Argentina, for example, show this dinosaur reached a length of about 36 feet. But the one in Australia was much smaller, measuring only around 6 to 10 feet long. And that's still plenty big. Basically, what we're saying is that the way predators were ranked in these 2 parts of the world was completely different. In South America, Carcharodontosaurs grew to massive T-Rex-sized giants, towering over megaraptors and dominating the landscape. But in Australia, it was the complete opposite. There, huge, powerful megaraptorids roamed the land alongside smaller Carcharodontosaurs. So the predator dynamic was different. And all of this just shows how unique the ecosystem in Victoria was back then. Although isolated dinosaur bones have been found in Western and South Australia, most of the fossils come from the eastern part of the country, like Queensland. And there, researchers dug up something really, really rare – a well-preserved dinosaur skull. The study shows that this bone belonged to the 4th discovered specimen of Titanosaur. This group includes those massive long-necked dinosaurs. They look like the Brachiosaurus, but some of them were even bigger, reaching 120 feet long. The skull, discovered in 2018, belongs to this guy, whose pronunciation is above my pay grade, and the research points out that it roamed the Earth around 98 million years ago. Thanks to this find, scientists were able to recreate for the very first time what its face might have looked like. Probably after checking out the illustration, they thought, hey, it looks a lot like its cousin. They were talking about another species of Titanosaur, this other unpronounceable guy. And guess where they used to live? Yep, in Argentina. So, this research also supports the theory that dinosaurs crossed between South America and Australia during the mid-Cretaceous period. Now, this wasn't the only secret buried in Queensland, though. In 2024, researchers working there discovered the fossilized remains of a new species of pterosaur, about 100 million years old. These creatures were the first vertebrates that could actually fly, existing alongside dinosaurs. They were massive, powerful predators with wingspans of up to 36 feet. But these remains belong to a new species within the pterosaur group, which they have named Hakuna Matata, or something similar. Compared to their cousins, they were on the smaller side, with a wingspan of about 15 feet. Still, that's bigger than a snowy albatross, the largest flying bird we have today. This species of pterosaurs were terrifying beasts, flying over the ocean to hunt for prey. Once they spotted their victim, they'd snap open their 60-centimeter jaws, filled with sharp spike-like teeth, and, well, I guess there was no escaping that. The last incredible discovery we're talking about today also comes from Queensland. For over 20 years, students walked past a plain-looking rock at Biloela State High School completely unaware that it held 66 dinosaur footprints, and they date back about 200 million years. These prints were made by a group of these Latin-named guys. They were small dinosaurs with 3 toes on each foot, and it seems like they were all over Queensland around that early Jurassic period. The rock they found at the school worked like a snapshot, giving us a better idea of what these dinosaurs were like and how they behaved. After taking a closer look, researchers found that the footprints came from 47 individual dinosaurs. This group was probably walking along or maybe crossing a waterway when their footprints got marked in the white clay. And the study also discovered that they were likely moving at less than 4 miles per hour at the time. So we only discovered those marks in Australia. But fossils of the same species found in other countries showed that they had these long legs, a big chunky body, short arms, and this tiny head with a beak. But honestly, they don't sound as scary when you realize they only ate plants. Whew. Baby T-Rex was adorable. There, I said it. Hard to imagine those 2 words in the same sentence, but come on, even Big Bad T-Rex didn't pop out of its shell all big, scary, and fully grown. In its first few months on Earth, Baby T was a cute, fluffy, turkey-sized ball of fuzz. It was kind of like a weird-looking bird coming out of an oversized egg. Not enough food, dangerous surroundings, asteroids, Poor baby T's were so helpless and weak, only about half of them made it to their first birthday party. Scientists think their fuzz was there to keep them warm when they were still small and vulnerable. Plus, it helped them camouflage and stay safe. Baby T's didn't have big, sharp teeth yet, so they mostly munched on smaller reptiles and insects. Baby T's grew up pretty fast. They put on up to 6 pounds a day. Hey, I've done that. No, not really, just felt like it. The weirdest fact about them? When they were little, their arms looked totally normal compared to their bodies. But by the time they were full grown, their parents were super famous, plastered all over t-shirts, that would be a T-Rex t-shirt, movies, and the greatest Halloween costume ever, in my humble opinion. But the T-Rex we know and love didn't really exist. First of all, speed. They weren't really that fast. In the movies, you could never get away from them, even if the path was clear and you were in a pretty decent car. Early predictions were that T-Rexes could run somewhere between 10 and 30 miles an hour, which is whoa! But recent research shows they could only reach around 12 miles per hour. Anything more than that would have shattered their massive bones. So relax. After a couple months of training, even the most dedicated couch potato could get away from the sharp teeth of this guy. And what about our good friend Stegosaurus? It lived around 150 million years ago, so it didn't even get the chance to meet those cute baby T's. They appeared much later. We all recognize this dinosaur. It's the one with those ridiculous upright plates on its back. They were sometimes up to 3 feet tall. You could hide behind one. Scientists still don't really know why they had them, but they think Stegosaurus could have regulated blood flow through them, like a massive bony thermostat. They also believe these dinos could use the same system to control their skin color, depending on whether they wanted to look good or look scary. Sounds impressive, right? Well, at least something about them does, because this poor thing had a brain that weighed just a tiny bit more than a tennis ball and was around the size of a walnut. That's a dog's brain in a hippo's body. Troodon was one of the most brainy dinosaurs. A great all-around fella, excellent hunter, stereoscopic vision, 6 feet long, and a brain that just won't quit. What a catch! Troodon's remains were one of the first dinosaur discoveries in North America. One of the weirdest members of the dinos was definitely, well, let's just call her Sue. If you met her, you'd feel like you're looking at a big turkey rat thing with a super furry body. It might be the long-lost grandma of the modern ground sloth. Its buddy, Pegamastax, definitely wasn't far behind when it comes to racking up the weirdo points. It looked like something between a porcupine and parrot. But don't say that to its face, it had a couple of pointy teeth that could sharpen against one another. The largest and one of the heaviest known dinosaurs was Argentinosaurus. No one ever found a complete skeleton, but this beast must have weighed about 100 tons and was about 130 feet long. Compare it to the biggest animal we have now, the blue whale. It's only 100 feet long. When someone says dinosaur, you probably imagine some big-as-a-building beast that could use a tree as a toothpick. Some of them were gigantic, true, like those long-neck, long-tailed dinos. Those things were as long as an airplane. But many of them were small and lightweight, some of them the size of pigeons. The smallest dinosaur skeleton ever found was a tiny mouse lizard. Some dinosaurs had tails that were more than 45 feet long. That way, it was easier for them to keep their balance when running. But they didn't drag their tail along the ground. Dinosaurs kept pretty active and were quite fast, so they kept their tails in the air most of the time. Even though that naughty asteroid wiped most of them out, a lot of dino DNA stuck around and morphed into animals we know today, like birds. The first time anyone even thought of linking the two together was after they discovered a primitive bird in Germany, sehr gut. Later, researchers classified two groups of dinosaurs, depending on what kind of hips they had. The first group looked pretty familiar. They had lizard-like hips. The second group had bird-like hips. And a third group looked like Shakira, which is where her tune My Hips Don't Lie comes from. Actually, no. Also, plenty of old-school carnivores had bones filled with air, which is something birds have too. Birds may be the dinosaurs' living descendants, but some animals actually witnessed the age of dinosaurs. If only they could talk. Snakes, bees, sharks, crabs, lobsters, yum, crocodiles, cockroaches, even green sea turtles. They all actually saw real dinosaurs. So jealous. Carnivore dinos mostly walked on 2 feet. That way they could be faster and have their hands free to grab a little snackosaurus. Plant eaters walked on 4 feet so they could carry their heavy bodies. Some of the bigger plant eaters needed around a ton of food per day, literally. Imagine animals so big they had to eat a house-sized pile of veggies on a daily basis. Still, a huge bush a day keeps the doctor away. Is that where that started? There are around 700 known species of extinct dinosaurs. Sounds like a lot, but we probably haven't discovered them all. 5 years back, they found out about a new type of dinosaur. It had these stubby horns right above its eyes, which looked so much like the comic book character. They named it Hellboy. Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice. In the 90s, scientists discovered a crater in Mexico's Yucatan Peninsula. You know the story. Around 66 million years ago, a meteor the size of Mount Everest hit our planet and filled the atmosphere with dust, gas, and debris that caused a serious climate catastrophe. It triggered a heat wave and a blast wave that went up into the atmosphere, partially blocking out the sun. Game over. Thanks for playing, dinosaurs. The age of humans never crossed over with the dinosaur era. Dinosaurs disappeared more than 60 million years ago, but they existed on Earth for 160 million years. Modern-looking humans have only been around for about 250,000 years. Only 59 million years to go, people. Not all the dinosaurs were on vacation in Mexico when the asteroid hit. They lived all over the globe. Some lived in deserts, while others lived in areas near ancient rivers surrounded by thick forests and rich vegetation. They weren't too picky, so they lived wherever, even Antarctica. But it wasn't covered in snow back then. Both poles had forests growing on them. Most people imagine all dinosaurs to be grayish-green because of the movies. Plus, we usually just think of them as giant lizards. Scientists still don't know much about dinosaur skin tones, but researchers recently found some evidence that dinosaurs totally embraced the rainbow. One little guy had white and orange rings on its tail. Dinosaur is Greek for terrible lizard. Scientists used to think dinosaurs were mostly cold-blooded like snakes, lizards, or other reptiles. Turns out they were wrong, maybe. Some evidence pointed to them being warm-blooded like mammals. Somewhere in 2014, scientists discovered that most dinosaurs were mesotherms, a little of this, a little of that. And it turned out many of them had feathers, just like little baby teeth. It helped them regulate their body temperature. Another thing we got from the movies and totally thought was real, what dinosaurs sound like. Producers usually mix together a bunch of animal noises to get that authentic dino roar. T-Rex is usually a mix of alligator, tiger, and the squealing of a baby elephant. And that dreaded T-Rex breath? It was just the sound of air going through a whale's blowhole.
Something exciting and kinda unexpected popped out among the rocks of the Ica Valley in Peru. The bones of a really old whale that lived almost 40 million years ago. At first, no one was really impressed because the bones they found were big and weirdly shaped, so people just thought they were looking at giant boulders. I mean, that's cool too, but things got way better when they realized those were the remains of a very large, ancient animal that roamed along the coast of ancient Peru. Plus, it was probably the heaviest creature that ever lived. Sorry, blue whale, I know you worked hard to get to the top. The length of over 100 feet and weight of more than 200 tons brought you the status of the biggest animal on our planet. But it seems you've held the title long enough. Time to hand it over to our next candidate, and that one's really gigantic. This ocean beast was probably shorter than the blue whale, but heavier, with a weight that could be between 93 tons and 370 tons. If it's closer to the higher number, it'll make Prehistoric the biggest animal ever known to have lived on Earth. And it seems its weight was the result of having extremely thick, dense bones. You can see such bones today in manatees or some other early whales. Dense bones are a great tool for such marine mammals. This feature makes them heavy and allows them to stay submerged most of the time. But at the same time, if their body was too heavy, they would end up sinking all the time, and they would waste too much energy to move back up to the surface. So, to avoid sinking, marine mammals need to have enough lighter tissues, like muscles and fat, to help them float in the water without using too much energy. Now, scientists didn't have the whole skeleton, which makes it hard to tell how big the animal was. But they used the ratio of the heavy bones to the lighter tissues in other marine mammals to estimate the overall weight of this giant ancient whale. Experts found these fossils about 13 years ago and spent the next decade freeing the whale from the rock. Its anatomy and age showed this whale was a cousin of Basilosaurus, a whale that had a long snout full of sharp teeth, and a sleek body similar to that of an eel. Even if Prehistoric wasn't bigger than the blue whale, it was still a giant that ruled the ocean depths. Unlike modern whales, there's a possibility that this ancient fellow was a predator that liked to go after bigger prey. And this also changes how we see the history of whales. Scientists used to think these magnificent creatures became really big about 5 million years ago when they started eating lots of small creatures. But here's the proof that giant whales existed even before that. But it's still unclear how this whale managed to find enough food to sustain its enormous body. Plus, it's still hard to tell what exactly this ancient creature had on its menu. It was pretty large and not such a fast swimmer, so it's possible it searched for food in shallow waters. Then it probably ate crustaceans, clams, or some other small animals hiding in the sand. One theory says it was a scavenger, which basically means it munched on remains of everything that would come its way. It's not so unusual to find marine animals in deserts. Many of these regions used to be covered with water anyway. The Sahara in Africa is a perfect example. About 50 to 100 million years ago, this was not a dry desert, but a shallow saltwater body called the Trans-Saharan Seaway. The land is not wet there anymore, of course, but people who lived in that area knew about it because they used to find old shells across the desert. The sea was about 164 feet deep. That sounds enough for a nice swim. Some would say this area looked like modern Puerto Rico, with lots of sun and shallow water. Mangrove forests were a common thing, as well as seafloors covered with mollusks, like snails and clams. The marine sediment that was left behind after the sea had dried up is full of different fossils. And the animal that lived in that ancient underwater world didn't look friendly. Plus, they were much bigger than their relatives from modern times, so a regular-sized human would end up as a snack, not even a whole meal. Normally, when animals live on small islands, they can become much bigger than their relatives from the mainland. This is something we call island gigantism, and it happens because there are more resources or fewer predators on islands. Maybe the same thing happened in the Trans-Saharan Seaway. Even though it wasn't an actual island, the water moved in and out, which created little pockets of water. And specific conditions in these pockets might have helped animals grow bigger. So we're talking about giant sea snakes, catfish, and fish that no longer exist today. One had incredibly strong jaws, and the animal used them to eat hard things and even crush shells. Their teeth showed they were fierce predators other animals had every reason to be afraid of. They went through some changes when it came to diet, similar to some types of piranhas. And the competition to get to the top of the food chain wasn't a joke. Not when there were also such large predators as sharks, crocodiles, and ancient relatives of elephants. Sahara went through different phases. If you could use a time machine and take a peek at Earth's largest hot desert as it was about 6,000 years ago, you wouldn't have to struggle with sand and heat. You'd have a nice walk through a green and pretty lush place. In the past, people who lived in that area didn't leave drawings on cave walls that showed camels, sand dunes, and scorpions. All those things you'd see in today's Sahara. Instead, they drew crocodiles. That's additional evidence that the Sahara used to have a lot of water and plants enough to support these big yet scary animals. Around 3 billion years ago, Earth might have been mostly covered with water. Today, it's about 71% of its surface, but it seems that our planet used to be a giant ocean world with no continents at all, just some scattered islands. Scientists studied special rocks in Western Australia that formed in a place deep under the ocean called a hydrothermal vent system. To explain this better, it's important to mention two common oxygen types, O16 and O18. O18 is heavier because it has extra neutrons. O16 evaporates from water more easily, and as researchers studied an old ocean floor, they found a lot of O18, more than in today's oceans. This way, they realized ancient Earth had less dry land than Earth today. Australia is a good spot to conduct these studies because a long time ago, it also used to be a beautiful place with large animals and lush rainforests. But as time went by, the land became drier and Australia had more deserts formed, such as the Great Victoria Desert. Rainforest remained only on the edges of the continent. What happens with deserts across the globe is called desertification. That's when land that used to be good for growing things turns into a desert or something similar. Our planet changes over time, together with its climate. But desertification also happens because of human activities, like mining, farming, and building cities. And when land turns into a desert, it's a problem because it can't support people and animals anymore. Food doesn't grow there. There's not enough clean water, and animals lose their homes. To help with this problem, there's a plan many countries agreed to. They decided to work with farmers to take care of the land, fix damaged areas, and manage water better. All in all, to make our planet a better place for life. When we look at creatures in the animal kingdom, we often have the following thought. If they have similar traits, they must be related somehow. Zebras, horses, and camels must have some common ancestor. Same goes for dogs and jackals. Somewhere back in their lineage, they must have some common great-great-great-grand wolf, right? Well, the way evolution works in nature is way more complex. Take, for instance, convergent evolution, which is when different creatures evolve independently from each other but end up having similar traits. We only need to look at sharks and dolphins to see how this works. At first glance, they look very similar, aquatic creatures with some species having roughly the same size. But turns out they're mostly unrelated. Sharks are fish. They reproduce by laying eggs and evolved to have the ability to sniff out blood in the water to feed themselves. Dolphins, on the other hand, are mammals. They're friendly and have a way more interesting social life. Take bottlenose dolphins, which have their own special whistles that they use similar to how humans use their names. Not only do they develop this type of whistle to introduce themselves to other dolphins, but they can also learn such names so they can better communicate with each other. Sure, sharks and dolphins did have a common ancestor, but this one lived in the sea almost 300 million years ago. It's safe to say, dolphins and sharks aren't even cousins these days. Another more shocking example of convergent evolution is that of whales and bats. Most of the creatures we can name on the top of our heads use light and sight to understand the world around them. But there is a specific set of creatures that relies on sound to paint them a picture of their environment. What they do is they emit a sound which bounces back to them depending on the object it hits. This ability is called echolocation. Animals that have this feature emit sounds at frequencies above human hearing, called ultrasound. Those sound waves bounce off objects while they move around, allowing them to figure out where they are in a certain space. Echolocation is mostly used by toothed whales and by some species of bats. What's similar in both of these animals is that they need to hunt in the darkness. Despite this, they echolocate in very different ways. Bats, for instance, use their throats to generate ultrasound from their mouth or nose. Then, they proceed to listen for changes in the echoes. Their echolocation is so finely tuned that they can distinguish targets less than 0.01 inches apart, even if their target is moving. Whales, on the other hand, echolocate by pushing air through their nasal cavity. This movement creates vibrations in a special fatty organ called the melon. This organ focuses and modulates the sound, which then passes into the water around the whale. Whales then pick up the reflections of these sounds through their lower jaw and around the ears. Another striking example of evolutionary convergence is that of ichthyosaurus and dolphins. Visually, the Mesozoic fish lizards named Ichthyosaurus seem very similar to modern dolphins. But the friendly mammals are much more related to giraffes and camels than the ancient creatures. Despite being 200 million years apart, they do share some common traits which mislead people into thinking they belong to the same species. But that's mostly because they lived in the same environment. They both evolved to feature dorsal fins, which keep them balanced while swimming. Now, let's look at Phytosaurus and crocodiles. The first ones were reptiles that roamed the Earth back in the Triassic period. They weren't dinosaurs, but they lived at the same time as the first dinosaurs did. Even though they look very similar, the first crocodiles popped up more than 70 million years later in the Cretaceous period. These two even fooled paleontologists at first. They initially assumed that phytosaurs were the ancestors of crocodiles. Placodonts and turtles look similar too. Placodonts, however, appeared about the same time as the dinosaurs did, somewhere around 235 million years ago. Like modern turtles, they lived in marine environments, but they were surrounded by predators. So, they evolved to have really strong shells to protect themselves. Turtles, however, made it to the scene around 100 million years later. Even modern cats have ancient lookalikes. They were called the Sparacidons, but they were carnivores and marsupials. They used to live in the South American area and resembled the saber-toothed tiger, which is now extinct. Speaking of saber-toothed tigers, how about one that's also related to the kangaroo? Yeah, this creature used to freely roam the earth around 300 million years ago. The Thylacosmilus may have looked like a feline, but it was a marsupial, meaning it had a pouch of skin in which it carried its pups for a certain period after their birth, like kangaroos and opossums do today. It's difficult to estimate what they looked like since a full skeleton has never been found, but we do know they weighed between 180 to 260 pounds. When we picture a present-day elephant, we always imagine them with their tusks protruding upwards. Well, that's not how their ancestors did it. About 20 million years ago, there lived a prehistoric elephant-like creature named Deinotherium. It did, however, have both tusks curving down from their jaw. As with many other prehistoric creatures, we don't know why they had this feature the other way around. But one theory suggests they used them as anchors. By securing themselves to riverbanks, they were able to safely sleep without drifting off. The last thylacine passed away in the early 20th century. Their extinction was one of the most tragic natural events in modern times. For the last 2,000 years, they have been known to live only on the island of Tasmania. Despite the name, they looked more like foxes than felines. However, thylacines were marsupials rather than placental mammals like foxes. The two-leg wallaby was one of the most beautiful and majestic creatures ever to have lived. It used to be found in Australia and New Zealand. They were very similar to the kangaroos and featured fine fur with shifting bands of darker and lighter gray across their backs. Surprisingly, they were dubbed monkey face, but they had no connection whatsoever to modern monkeys, apart from both being mammals. What made them so special was the way they moved around. Their standard movement consisted of 2 short hops, followed by a long one. After that, the wallaby would simply stare into the sky. Don't be fooled though, the two-legged wallaby was extremely rapid. Females were generally taller than males, and they appear to have been quite sociable animals, at times being particularly fond of a certain location. They were also nocturnal. Hyracoodonts and horses share a lot of similar features, but hyracoodonts used to exist in the Eocene and Oligocene periods, and they went extinct around 23 million years ago. In their whole group, they featured very diverse species and came in many different sizes, from the small pony-like to the colossal Paraceratherium, which is one of the largest land-living mammals ever to exist. Modern horses, however, appeared around 2 million years ago. Let's do a little experiment together. Start by stretching your arms out. If you were to draw a line from your fingertips to your shoulder, it would measure around 28 inches. Now, try to picture an insect with a wingspan this big. Hold on a minute, you won't need a large can of bug spray, don't worry. They're extinct. But the gigantic Meganeuropsis did live around 250 to 300 million years ago. However, they most likely resembled the present-day dragonflies, despite not being technically related. Scientists figured out that they were not true dragonflies because of differences in the shape of their wing veins. Scientists still don't know why these bugs turned out so big. Some believe insects are limited in size because of the small quantity of oxygen they're able to take in. In the times when these insects roamed the Earth, the levels of oxygen in our atmosphere were much higher, so that might be one explanation. Other specialists think that they got so big because there wasn't any other predator large enough to pick them up from the ground.
A piece of whale rib has recently been found in a North Carolina mine. Not a big deal, some might think. Hey, why can't a whale be a miner, right? But this fragment offers scientists a unique glimpse at the interactions between prehistoric sharks and whales from around 3 to 4 million years ago. The thing is, 3 tooth marks embellish the rib. That means that the whale was once badly bitten by an animal with a super powerful jaw. Judging by the spacing between the tooth marks, and it reaches almost 2.5 inches. This animal could be a mega-toothed shark, I'm talking about the megalodon. Or it could be a different shark species which was around at that time. The curvature of the shark's jaw shows that the animal was relatively small, between 13 and 20 feet long. Yeah, small. As for the whale, it seems to be the ancestor of a great blue or humpback whale. Researchers are amazed. You don't usually expect to find evidence of animal interaction and behavior preserved in the fossil record. After examining the sample carefully, they concluded that the shark must have gone away with a mouthful, but the whale had survived because most of the fossil fragment is covered with what is known as woven bone. It quickly forms in response to localized infection. Such bone isn't particularly strong, and later the body remodels it into compact bone tissue. But it takes time. The presence of this bone means that the healing was incomplete and the whale passed away 2 to 6 weeks after the unfortunate encounter. On the other hand, its demise could have been unrelated to the infection and injury. Only a handful of fossils show such kinds of interactions between ancient animals. You can often find bite marks on fossils indicating where the animal passed away and its carcass was scavenged. But this fossil is one of a few examples that not only show a wound inflicted by another animal, but also demonstrate that the prey survived. All fossils are exciting for paleontologists. Yes, they need to get out more. But some might look terrifying to regular people. For example, look at this picture of tentacle arms and octagonal-shaped heads. When it first appeared in mass media, internet users claimed that it was some ancient organism that had come from space. Others thought the story was fake, but in fact, both the picture and the fossil are real. The fossil is known as a mortality plate, a fossilized representation of a mass extinction event of one or several species. The fossil actually contains more than a dozen specimens of a type of marine organism called a crinoid. Despite their looks, crinoids were not plants but marine animals. This particular species lived deep underwater on the seafloor. Crinoids were related to starfish, sea urchins, and brittle stars. These creatures could attach themselves to the seafloor with stalks made up of flexible porous discs connected by soft tissue. The stalks were hollow, and that's where the animal's nervous system was located. Crinoids absorbed oxygen through thin-walled tube feet. The creatures usually reached the length of more than 8 inches and had 5 arms lined with leathery-looking tentacle-like structures. They fed on plankton and sloughed off organic material. Now, even though these fossil finds seem to be super exciting, few creatures in the fossil record confuse scientists as much as the Tully monster. This curious sea creature sported a toothy, trunk-like snout and eyes splayed out on a rigid rod. But the most bizarre thing? It has been impossible to classify. Researchers have been considering a variety of organisms, for example, segmented worms, swimming slugs, and primitive eel-like creatures, since the monster was discovered in 1966. Recently, they have even tried to connect it to some species of jawless fish with a backbone-like structure. A team of scientists from Japan has used high-resolution laser scanners to examine the anatomy of Tully monster fossils in 3D. They concluded that the enigmatic fossil might be an invertebrate after all, and still, the true identity of the creature remains elusive. In the 1950s, amateur fossil hunter Francis Tully found a ghostly imprint of a torpedo-shaped organism with a huge tail fin in the Mizon Creek fossil beds in Illinois. Tully had never seen anything similar to the torpedo structure. He took his find to Chicago's Field Museum of Natural History. Paleontologists working there were baffled as well. Since then, scientists haven't been able to determine where the creature fits on the phylogenetic family tree, or where they should spend Thanksgiving. In 1741, an explorer and captain named Vitus Johansen Bering led an expedition to map the coast of Alaska. The ship he was on got shipwrecked on what later became known as Bering Island, and they got hungry. Half the crew survived thanks to the discovery of an extremely large sea cow. With the meat of these animals nourishing them, the sailors managed to build a small ship from the wreckage and return home. On their way back, a scientist who was among them spent his time documenting the animals and plants they had found. The sea cow was particularly interesting because without it, the crew wouldn't have survived. These animals were more than 26 feet long and weighed around 10 tons. All sea cows are member of the order Sirenia, marine mammals more closely related to elephants than cows. The The scientists described them as having black skin, a small head, and stubby forelimbs. Those sea cows floated on the water's surface, munching on kelp. After the information about these animals became widespread, sea otter fur trading expeditions made use of that convenient depot en route. Sea cows were docile and could be easily hunted. Long story short, within 27 years after the scientists mentioned those animals, they were driven to extinction. But it's not the saddest part. The fossil record reveals a much deeper and darker history. Fossils of sea cows have been discovered all over the world, from Japan to Mexico. It means that the animal once thrived in the vast kelp beds around the entire North Pacific Rim. That small population discovered by the expedition was probably the last remains of a once much larger and way healthier population. More likely, Aboriginal hunting had already reduced the numbers of these animals to near extinction levels, and the final blow came from Western hunters. The living close relatives of those ancient sea cows are rarely hunted today. Still, they're under threat of extinction themselves. To some, this amazing fossil might look a bit disturbing. Slaves' lentils are fossils that belong to animals called nummelites. They lived and thrived in a warm, shallow sea covering part of Egypt around 40 million years ago. The name nummelites hints at the fact that larger specimens resemble coins, and in Egyptian folklore, they're even referred to as angel's money. These creatures have a simple, single-celled structure, which contrasts with their super intricate skeleton. Look at this series of spiral overlapping whorls. Each whorl is divided into countless tiny chambers. Nummelites can grow to be 4 inches in diameter, and still, they are the fossils of single-celled animals related to amoeba. How and why did they grow to be so large? The reason could be their symbiotic relationships with other smaller organisms. In the case of modern species, such symbionts are tiny golden-brown single-celled algae called diatoms. The shells of nummelites are relatively transparent, and since they're flat, there's a large surface area for the light needed for the diatoms to photosynthesize. For some reasons, scientists are still debating about them. The presence of plant symbionts in animals dwelling in the sea encourages the growth of a calcareous skeleton in hosts. So, the gigantic size of the nummelites in Egypt could be due to their close relationship with symbiotic diatoms. Does that make sense? Fun fact: a species of nummelites evolve very fast, and their fossils change from one layer of sediments to the next. So, the limestone used for the pyramids of Giza are so packed with such fossils that it's known as nummulitic limestone. This limestone also contains 2 kinds of nummelites, the smaller slave's lentils and the larger angel's money. But those are not different species, but rather different stages in the life cycle of a single species. So, we all know that Mother Nature is wise. If she blesses some creature with a particular body part, it should make perfect sense, right? Well, yeah, but still, some wildlife shots make you wonder if evolution has gone the wrong way. Snakes' natural design allows them to swallow a whole mouse. But in some cases, this cool ability can turn against them. Yes, snakes can actually swallow themselves. Scientists believe that they mostly do this because of stress, captivity, temperature regulation, hunger, or illness. The snake is pretty helpless in this situation, you can tell. If it doesn't get help in time, digestive juices may begin to corrode the swallowed tail. So, if you ever catch your pet snake doing this, try to stop it, or take it to the vet. Okay, but what about the fangs, I hear you ask? Does a venomous snake have immunity to its own venom? Well, if the snake digests it, it will be okay. It's because protein is a primary component in venom. And besides, the venom is excreted by the gland in the snake's mouth. So, no matter whom the snake bites, chances are that it's going to drink a bit. So the only way a snake can actually suffer from its own venom is by biting itself straight into the blood vessel. In this case, it'll experience the same reaction as any other animal. Now, think you're having a bad hair day? Hey, check this guy out. Chris was an Australian merino ram who became a celebrity in 2015 after being discovered in the wild. Farmers shorn him and gained nearly 90 pounds of wool. When the animal was found, he carried over 5 years' worth of fleece on his body. But Chris belonged to the domestic sheep breed that needs to be shorn regularly. Otherwise, the animal is at great risk of injury and infection. So the lives of these cuties depend directly on going to the hairdresser. Shall we talk about horns? Cattle, goats, and many other species proudly wear this fancy headdress not only for fashion, but also as a weapon for brutal battles. If you ask this bighorn sheep ram directly how old he is, you'll probably hear something like, "Bah." But if you want to get a more precise answer, you can count the number of rings on his horns. The biggest and the darkest ring usually marks the 4th birthday, when the ram matures enough for mating. Although animal horns may look very tough, in fact, most of them are made of keratin. It's the same protein that builds human hair and nails. Horns never stop growing as the animal ages, just like our own hair. And eventually, they can curl into really extravagant shapes, making these weapons turn against their owners. This is what a Wiltshire sheep horn looks like when it's young. But as the years go by, the horns typically curl in front of its face. And while most grow out harmlessly, the inward-growing horns can end up dangerously close to the sheep's head. Like this ram who's having bad luck, to say the least. Its horn has slowly grown into its own skull, and eventually, well, it didn't end well for the sheep. Of course, this would hardly have happened on a farm, because people would have made a preventive horn cut. But unfortunately, in the wild, animals cannot use hairdresser services. That's why they use rocks and branches to rub and grind away at their horns to keep them safe, just like humans trim their nails. Faulty genetics is not the only reason for the horn distortion. You see, when males of the species want to fight for dominance, they begin to butt heads to show each other who's the alpha male here. These battles can break horn plates, making them grow at weird and dangerous angles. The fancier the original shape of the horns is, the more problems their fracture may cause. This poor African kudu is a bright example. Fortunately, in some cases, unlimited body part growth can be good for the animal. Just take a look at these adorable smiles. If you happen to break off your own molar tooth, your dentist would probably say it's irreversible and offer a replacement. But if an alpaca breaks its front teeth, all it has to do is wait a bit. Although these animals don't have upper teeth, their lower teeth constantly grow throughout their lifetime, and they might look pretty creepy when they get too long. That's why some farmers prefer trimming them from time to time, just like pet owners cut the nails of their cats or dogs. Now, llamas look so similar to alpacas that many people confuse these two species. But the significant difference between them is that llamas' front teeth are encased in enamel. That's why, unlike alpacas, they don't possess the superpower of limited growth. Too bad. Unlike the keratin horns, deer antlers are made entirely of bone. Typically, only male deers, called stags, grow antlers. Very rarely, females can grow them too due to a serious hormone imbalance. This is a deer equivalent of a beard on a human female that sometimes can appear due to various diseases. Adult deers grow and shed their antlers annually, which coincides with the breeding season. At first, their antlers are covered in velvet, a protective skin with blood vessels. But once the antler is fully developed, the deer gets rid of the velvet, just like snakes shed their skin. Although this process doesn't harm the deer, it may look pretty spooky. Once the brand new antlers are ready, stags begin to fight with other males over the ladies' attention. Usually stags barely eat or sleep during this competition. And if you ever question whether the antlers of two deers can get locked together, the answer is yes. Every stag is risking ending up stuck with his own rival instead of having a romantic night out with a female deer. Bummer. Moreover, all the traumas that the deer gets during the mating season can influence further antler growth if specific nerves get damaged. Just like horns, antlers can develop at distorted angles because of genetic failures. Some mutations can even make them grow monstrously large. This unlucky deer can barely move his head without losing balance. Also, if a deer breaks one of its legs, its body can speed up the healing by sacrificing the bone and blood material from one of the antlers, and thus this antler will get thinner and weaker. And speaking of facial extensions, we cannot skip the tusks. Please meet Babirusa from Indonesia. This ancient boar first emerged over 35,000 years ago. It's easy to confuse these big tusks with horns, but they are actually upper canines. They tend to pierce through the skin of the boar's face as it matures. Scientists believe that these intimidating tusks have evolved as a tool to protect eyes and throat while fighting with other males during mating season. But this design doesn't seem very thoughtful. If a male boar doesn't grind his tusks regularly, they can end up curling back into his own skull, which can blind him or even worse. Now, what if I told you that hoofs can grow out of control just like horns and antlers? It took evolution millions of years to turn the middle toe of the animal's foot bone into the hoof. And just like toenails, they tend to grow and curl into creepy shapes if they aren't cut regularly. When donkeys or horses don't have a chance to wear down their hoofs naturally by walking on hard surfaces, they tend to overgrow. This makes the animals walk on the balls of their feet and overstretch the tendons, which may result in pain and bone loss. And eventually, they can lose the ability to walk at all. So if you ever come across a horse with curly hooves, consider calling the experts to give it an emergency manicure. Perhaps one of the most obvious questions regarding the undersea world is, can a fish drown in the water? Yup, it can. Although gills are an amazing gift of nature, there are still many factors that may deprive a fish of healthy breathing. When the oxygen level in the water is too low, fish begin to suffocate. But it happens very rarely in the wild. Oxygen deficit usually appears in aquariums that are not washed and replenished often enough. Also, parasites, diseases, and an overall imbalance in water components can cause the fish to drown. And on that note, I need to hoof it on out of here. See you next time. Now here's something. Baltic amber is one of the most common resins found in the world. The reason for this is that due to the vast forests of pine, their numerous deposits are so common, they provide wonderful treasures from long ago. Ants are especially common in the Baltic amber, which comes from pine trees. Its resin is rich in sugar, so the ants often live amongst the trees, close to the easy source of food. One block found in East Germany has preserved one ant that is estimated to be about 48 million years old. Think of the birthday cake. But what makes this find interesting is another animal inside the amber. It's a mite, notorious hunters in the insect world, capable of traveling at great speed. These guys quickly latch onto their hosts, sucking them dry. They're also capable of destroying entire hives in one go. And within this piece of amber, the amber provides a display of their final struggle. In Southeast Asia, feathers belonging to something unique have been found from 80 million years ago. They were captured in resin during the Cretaceous period, a peak time for dinosaurs. The many feathers inside are from the coelurosaur. It looks like a dinosaur, but this animal is more related to birds. Other feathers like this have been found in resin. They belong to avian and other non-flying dinosaurs. The discoveries have helped reimagine what dinosaurs actually look like. Still, dinosaurs may have had feathers instead of being completely bald. Of course, for most of them, the feathers weren't used for flying, but they helped the dinos stay warm. However, the feathers weren't all that was found, and a part of the coelurosaur's tail is also preserved. Still, it's so small and ancient that its DNA hasn't survived to map their entire genome. The enclosed tail is also very delicate, and it can't be removed from its protective amber shell. But although these findings can only be observed, they've still provided a great insight in the evolution of birds. But how does amber preserve things so effectively, even at the initial stages? The trees produce the resin to protect any small gaps in the bark against feeding insects. Its antiseptic nature and lack of water content ensures it doesn't degrade for a long time. This also makes it more resilient as it petrifies over long periods, eventually becoming a fossil. Some of the oldest amber ever found was from the Triassic period, showing how long it can last. The pieces from Italy are about 230 million years old. And inside one of these ancient droplets holds the oldest arthropod ever recorded. This mite found inside has provided a broader understanding to their evolution. Today, they're known to mainly annoy gardeners by feeding on the petals of flowering plants. However, at the time the mite was caught, flowers didn't have any petals, and it would be without this tasty meal for another 100 million years. Now, 100 million years ago, Myanmar was part of Gondwana, the great supercontinent. At that time, Myanmar wasn't part of Asia yet. But it was still lush with a great forest, which contained many species of lizards that lived amongst the undergrowth, hiding away from dinosaurs. Many of them have been stored within amber. This fact helped discover ancestors of geckos and chameleons. By using CT scans, scientists have analyzed them, providing a glimpse into the formation of their scales, teeth, feet, and claws. It also provided an understanding of how these archaic creatures once appeared. Although mostly pieces of lizards, by using modern technology, the scientists have been able to create 3D images of the lizard. These images can reveal how those guys appeared in their full form. The images show that they still retain some of their exact features to this day, like the chameleon's sticky pads used for climbing. A salamander fossil from around 20 million years ago is one of the most intact specimens ever found in amber. Details of its final moments show that it had been attacked before getting stuck in the resin. However, what's confusing about this find from the Miocene era is that the amber was found in the Caribbean, but it came from a tree that's closer related to those from East Africa. The lizard also has ancestry from the same area. Finds like this have opened a whole new understanding about how these small lizards migrated. It's expected that they would have ridden fallen logs, which took them across the seas to new homelands, not only to the Caribbean, but to all continents except for Antarctica. Nobody goes there, it's too cold. In the Dominican Republic, you can find some of the rarest of all ambers. This Dominican amber came from neotropical forests from around 20 million years ago. Many of the trees that made the resin are now extinct. The amber is almost completely see-through and can come in an array of beautiful colors. The most common colors are red, yellow, and even blue, and are easily mistaken for gemstones. One was found with a flea caught in it, dating to when the forest was at its peak and the mammalian variety thrived. Fleas were likely common at the time, and this flea in particular had recently fed on a mammal before getting stuck. However, something more intriguing was found within the flea. While scientists checked what mammal DNA was within the flea, they found that it was carrying an ancient bacterial blight. These blights have been constant throughout Earth's history, dramatically decreasing populations of animals and plants. This now extinct blight in the amber helped scientists determine how much the bacteria have evolved and how it spread. Now, most remnants of insects inside amber aren't much more than the exoskeleton bodies. But with some found in Myanmar, they were so well preserved that even the color of the insects is still intact. Colors in nature appear in 3 different ways. The first is bioluminescence, that's produced by a chemical reaction within a living organism. The second is about pigments, where the color appears in an animal or a plant tissue. The third is called structural coloration, and the production of colors here is explained by microscopic surfaces fine enough to react with the light. The rare insects in amber were found in the form of structural coloration, but only at specific wavelengths. It all explains the very intense colors rarely found. 99 million years later, these bugs can still show their vibrant colors – blue, purple, and green. Some of them appear so different in color and shape that they almost look like they're from another world. Which of course they are, a very old one. Ants have been around for about 168 million years, based on fossil evidence provided. They're well known for their social hierarchies and their hive mind system. They've dominated almost every corner of the insect world, but when these social capabilities came about have been difficult to determine. Yet, recently, amber dated from 100 million years ago has shed some light into their evolution. Several amber pieces have preserved various ant types, including the worker ants, guardian or soldier ants, and even a queen ant. Before these pieces were found, it was estimated their social nature occurred millions of years later. A piece of amber dated 100 million years ago helped shed light on the evolution of birds. A perfectly preserved bird that hatched preserved in amber was already equipped with its flight feathers. With the earlier physical abilities, they would be capable of moving around the nest by themselves at a very young age, and it's expected they could search for their own food almost immediately. But as birds continue to evolve and spend more time in the skies, their brain developed larger for their cognitive abilities. After hatching, their early development was then more focused on the brain, and the chicks slowly became more reliant on their parents over time. In Spain, a massive treasure trove of amber and other fossils has been found. Inside, there were remnants of an entire ecosystem that existed 110 million years ago. A bunch of individual fossils were found. The vast collection includes many types of insects, mollusks, arachnids, plants, 50 different dinosaur bone fragments, feathers, and hair from mammals, and a McDonald's burger wrapper. Nah, just kidding. With the abundance of findings, it's helped researchers understand the ancient terrestrial ecosystem that once existed. With loads of specific details of the environment, they've reconstructed the swamp. This way, it's now possible to experience what it was like in the world of dinosaurs.
You decided to go scuba diving for the first time. The water is clear and the sun is shining on the seabed. You take a few selfies and the fish swimming by when suddenly, the ocean goes pitch black. You look up and, oh my, what is that gigantic animal? It's definitely not a shark, not a whale. Is it a turtle? Yup, but fear not, it's not gonna hurt you. If you had lived on this same Earth about 72 million years ago, then maybe this could have really happened to you. Scientists have recently found the fossils of a gigantic marine turtle that could have grown as big as 12 feet. If you don't have any idea of how big that is, let's see some examples. That's the average length of a hippopotamus, 6 golden retrievers, or 2 Michael Jordans stacked on top of each other. The turtle's scientific name is an homage to that old-school sea monster called Leviathan. Maybe you remember this from old-school history lessons. The Leviathan is supposedly a mythical creature that would swallow entire ships or people that were deemed too greedy by the creature. Can you imagine being swallowed by this humongous sea turtle? No, thank you. The fossils of this gigantic creature began to be excavated between 2016 and 2021, all the way in northeastern Spain. The first fossil was located by a hiker in the Spanish Pyrenees, and it was around 8 inches long. The pelvis of this turtle alone measured around 35 inches. It would definitely be one of the biggest turtles today if it hadn't gone extinct. FYI, the largest living sea turtles today can reach up to 6 feet in length, which is already pretty big. Now, how about a gigantic prehistoric scorpion? I bet most people here are not huge fans of these creatures, especially since they're poisonous, which is why the thought of a 9-foot-long aquatic scorpion might be the stuff of nightmares. Let's just say that if they hadn't gone extinct some 400 million years ago, lakes and rivers would be much more dangerous places for humans today. These gigantic insects were considered to be apex predators in their time, hunting everything from fish to other animals, even of their own kind. Yikes! I got goosebumps just imagining these creatures. Should we thank the asteroid that hit our planet now or later on in this video? Another prehistoric animal that would shock humans if it were still alive is the so-called Megatherium, a gigantic sloth. This huge sloth is believed to have grown up to 20 feet long, and its weight could be up to 8,000 pounds. It was found in the woodlands and grasslands of South America. The creature used to stand on its 2 feet in order to reach leaves on high branches. These giant sloths had huge claws. They helped them climb trees. I gotta say, I feel uncomfortable imagining these elephant-sized sloths climbing trees. Oh, of course, some dinosaurs will make our super-sized creatures list. But before that, here's a fun fact. Did you know some dinosaurs are still alive today? Scientists have proven that birds are classified as theropod dinosaurs. Such infamous creatures as the T-Rex and Velociraptor belonged to this group. I'm sure you've heard these names even before you watched Jurassic Park. The Velociraptor is that scary dino that breaks into the kitchen. Well, they evolved, gained some feathers, and turned into various species of birds we know today. That means that any bird from chickens to those little blue ones is a direct descendant of dinosaurs. Now, does the name Spinosaurus ring a bell? You can see this huge dinosaur in some museums today. Its fossils, I mean. The Spinosaurus was one of the biggest land predators to walk Earth. Actually, to walk its land and water, since scientists believe that this dino was semi-aquatic. It fed mostly on meat, which means humans would be its natural prey if it lived today. This meat-eating dino lived around 90 to 100 million years ago. It was about 60 feet long, 12 feet high, and weighed up to 22 tons. Its head was around the size of 8 bowling balls and was shaped like a crocodile's face. Basically, the Spinosaurus was a big African elephant with the face of a crocodile. Just kidding. But that would look funny though, wouldn't it? A much more attractive dino was this guy. It's considered to be the largest dinosaur that has ever lived on our planet. What made it so big was its extremely long neck and very long tail. You wouldn't want to stand behind this creature, believe me. If it decided to swish its tail, you'd get catapulted very far away. This creature lived around 100 million years ago, and its fossils were first found in Argentina around 2012. The dino measured 120 feet from head to tail, which made it almost as big as an American football field in width. And have I mentioned it weighed almost as much as a space shuttle? A staggering 75 tons. If it had been a carnivore, it would have probably been the greatest predator. But this big guy was a peaceful herbivore that had such a long neck that it could eat leaves from high trees. Cute, right? We must also talk about the Shastasaurus. As the name suggests, this animal is popularly known as the Mount Shasta lizard. Even though it was a marine reptile and probably never set foot on the mountain itself, this dino was usually around 23 feet long, but there was a specific strand of this species that could get as big as 69 feet long, about the size of the great blue whale. This made it the biggest marine reptile to have ever lived. A fun fact about the Shastasaurus is that scientists believe it didn't even have teeth, which means it could only feed on soft-bodied prey, such as squid, for example. The next animal on our list is the blue whale. Believe it or not, the biggest living animal on Earth actually started small. These days, the average mature blue whale can reach up to 100 feet in length and weigh up to 200 tons. That's more or less the weight of 40 elephants put together, or 30 Tyrannosaurus rexes, or 2,670 average-sized people. Blue whales have to eat up to 50 million calories per day to support that body. That's the equivalent of 30,000 Big Macs, just FYI. But blue whales weren't always this big. They actually evolved from a four-legged mammal that lived on Earth around 48 million years ago. Their ancestor was called Pakicetus, and it was only 6 feet long. Here's a fun fact. To be able to live in the water as one does today, the blue whale had to go through some intense adaptations. A blue whale can replace up to 80 to 90% of oxygen in its lungs each time it takes a breath. A human replaces only up to 15% for comparison. It allows these animals to dive for up to 1 hour at a time, down to a staggering depth of 330 feet. Elephants were bound to make the list. Elephants are currently the largest land animals on Earth. They can grow to be about 13 feet tall and weigh up to 7 tons. That's pretty small if we compare it to the other animals that once lived on Earth, right? If we placed a 6-foot-tall human next to an elephant, we'll see it's not at all that small. African elephants are bigger than their close relatives, Asian elephants, and they have a similar lifespan to humans, up to 70 years. Pokemon might have made us collectively wish that salamanders were real-life dragons, although they're not. They can still be pretty cool though. There's a giant species of salamander that is known to be the largest living amphibian. They can grow to be as long as a regular-sized human, reaching up to 6 feet. I bet that wouldn't be a pleasant underwater encounter.
Well, there you are. The sun is scorching, you're thirsty. All you can think about is water and ancient bones under your feet. You're wandering through the Sahara, the largest hot desert on Earth. Right now, you're crossing a stretch of sand called Whale Valley. And all over these 75 square miles of land, fossils cover the ground so thickly that you can't help but step on them. Paleontologist Hesham Salam says it's an unusual picture in this place. The bones are poking right out of the cliffs, as if they're calling to you to come check them out. You can spot ribs scattered all over the place. Look at these vertebrae. They're giant. Ooh, the creature they once belonged to must have been up to 65 feet long. The fossils show that the animal had a streamlined body like today's whale, but still had features like hind legs and feet. For scientists, it means a very exciting thing. They might have discovered a fully intact skeleton of a prehistoric whale. It was an animal that lived in this area when Egypt was underwater. You see, today, the Valley of the Whales is the world's largest ancient whale graveyard. You're likely wondering what marine animals are doing in a desert more than 100 miles away from the nearest coast. Well, millions of years ago, this desert was at the bottom of a massive ocean called the Tethys, which stretched from Europe to India. When sea levels dropped, the ocean left behind a seabed covered with fossils. And today, the fossils of some of the earliest known whales rest here, which gives researchers a peek into how today's massive ocean whales may have evolved. The fossils here are super detailed, even with some stomach contents still intact. Uh-oh. Scientists have also found fossils of ancient sharks, crocodiles, and turtles, helping to recreate what this marine world looked like millions of years ago. Now, the first whale bones were discovered in 1902, but it wasn't until the 1980s that people really started to explore the area, only when access to this area became better. Sadly, some fossils had been taken away by collectors before the site turned into a protected area. Most of the fossils are just under the surface, slowly revealed by erosion. Whale Valley gives us an amazing glimpse into millions of years of ancient coastal marine life. But let's move further. Ancient whale fossils aren't the only discovery you're going to make today. For over 150 years, scientists have been puzzled by a strange creature that lived millions of years ago. But now, thanks to some amazing fossils found in Morocco, they've finally figured it out. Look at them. These creatures are called blah blah blah. Nah, I'm kidding. Stylophorans. They look like flattened armor with a long arm sticking out. Researchers discovered these creatures in 2014 and were shocked. The fossils dated back around 478 million years. They found around 450 specimens, and to their surprise, some even had soft tissues preserved, which is super rare. Before this, they only knew stylophorans from their hard parts. Originally, scientists thought these creatures were good old echinoderms, animals like sea urchins and starfish. But new discoveries prove that they had a core body and feeding arm similar to modern starfish, complete with a water vascular system to help them move and eat. This finding ends a long debate about where stylophorans fit in the animal family tree. Now we know they're related to echinoderms, but are more advanced because they don't have the typical 5-ray symmetry. Ooh, come here and look at this giant fossil. It was found in the Sahara and gave scientists new insights into the Spinosaurus, the largest carnivorous dinosaur we know about. These 95 million-year-old remains also confirm that it was the first known swimming dinosaur. The Spinosaurus had flat paddle-like feet and nostrils on the top of its crocodile-like head, perfect for staying underwater. It was a pretty weird dinosaur with a long neck, trunk, tail and a 7-foot sail on its back, so it must have spent a lot of time in the water. At over 50 feet long, Spinosaurus might have been even larger than T-Rex. The first Spinosaurus remains were discovered about 100 years ago in Egypt. But only this new fossil, found in Morocco, helped scientists reconstruct this dinosaur for the first time. Researchers paid attention to the creature's shorter hind limbs and wide claws. These features point to adaptations for life in the water. Its snout and dense bones also suggest it was a swimmer, while its spiked tail likely attracted mates. Hey, good looking, come here often? And here's another astonishing find made in Tunisia, the remains of Machimosaurus rex. Now, so far it's believed to be the biggest crocodile ever. This ancient croc was about 32 feet long and weighed around 66,000 pounds. It was a top predator around 130 million years ago, and its skull was over 5 feet long. Now, this discovery is a big deal because it shows that these crocs stuck around longer than we thought. Before this, scientists believed that they disappeared during a minor extinction event between the Jurassic and Cretaceous periods. Now, let's go back to the fact that the Sahara was once underwater, and some of the largest sea creatures ever lived there. A study published in the Bulletin of the American Museum of Natural History speaks about an ancient body of water called the Trans-Saharan Seaway. It existed between 150 million years ago, covering parts of Western Africa. Scientists spent 2 decades trying to recreate this prehistoric underwater world. They found it was warm and shallow, home to some pretty terrifying creatures, including 5-foot-long catfish and 40-foot-long sea snakes. Yikes! The seaway was cut off from larger oceans for long stretches, which may have helped these predators grow larger because resources were always available. It's a classic case of evolution at work, leading to what scientists call gigantism in isolated environments. But all that water didn't just disappear with no trace. Under the sands of the Sahara, scientists have discovered a massive ancient lake, which they're calling a megalake. Makes sense? This lake formed around 250,000 years ago when the Nile River flooded the eastern Sahara. At its biggest, this lake covered over 42,000 square miles. It's about half as big as Kansas. They also found evidence of a smaller lake, 93 miles west of the Nile, at a slightly lower level and covering 18,600 square miles. All of this adds to growing evidence that once, North Africa had many lakes that might have created migration routes, helping early humans move across the continent. Now, in the Sahara, you can find not only fossils of bizarre animals. In May 2020, some weird rocks with greenish crystals were discovered in a sandy region in southern Algeria's Sahara Desert. When scientists checked them out, they found out these rocks weren't from Earth. They were actually pieces of a meteorite called Erg-Chek 002. This meteorite is super old, like the oldest volcanic rock ever found. It melted ages ago in the fiery heart of an ancient protoplanet that no longer exists. Researchers had recently published a study in Nature Communications, revealing that they have analyzed lead and uranium isotopes in Erg-Chek 002 and found out it's more than 4.5 billion years old. Another cool discovery made in the Sahara is quite unexpected. A few years ago, scientists found what they think are the world's oldest colors, and they're bright pink. These pigments were uncovered from rocks that are around 1.1 billion years old in the Sahara Desert. The colors came from microscopic organisms, as animals didn't exist back then. The discovery was made by a PhD student who crushed the ancient rocks and analyzed the pigments. These pink pigments are actually ancient chlorophyll from photosynthetic organisms that lived in an ocean that's long gone. Researchers are now sure that this finding could help explain why larger, complex creatures showed up much later in Earth's history. Before these colors were discovered, scientists didn't know what was missing in the food chain that delayed the evolution of larger animals. Now they understand that tiny cyanobacteria were at the bottom of that chain. Apparently, this discovery is not just about finding some old pink stuff. Scientists believe it's a breakthrough in understanding the history of life on Earth. In July 1990, 4 Czech guys decided to go on an adventure to find the Mongolian death worm, the creature that might have inspired the monster you've seen in the movie Doom. They say it lives somewhere deep in the Gobi Desert, so they flew to Mongolia, hopped into an ATV, and hired some local guides to help them. All that to meet a creature that is up to 6 feet long, can spit acid that could melt anything, and is capable of shooting electricity at those it doesn't like. Legend says that these friendly guys spend most of their days hiding underneath the sandy dunes, but they'd like to come out during the wetter months of June and July. So the timing for a spotting was simply perfect. But the crew needed to figure out how to lure the creature. Sadly for them, no one knew what the giant worm liked to eat. So they built a thumper, which is a machine that made rhythmic pounding noises. They were hoping it would call the worm out of the ground. For 2 months, they searched the vast desert, crossing dunes and rocky plains, looking for any sign of the creature. But alas, it didn't really work out. Ivan McCurley, who was the leader of the 1990 expedition, came back to Gobi Desert again. He once tried to attract the megaworm with blasts, and the second time he used a small airplane to scout the dunes. Over the years, groups from America, Britain, and New Zealand organized big expeditions to the Gobi Desert to try and find the creature. Many others came from all around the world on their own and found nothing. The people in the West first found out about the megaworm of the Gobi Desert thanks to an American paleontologist, Roy Chapman Andrews. This brave man was probably the inspiration for Indiana Jones. In 1926, he wrote about the creature in his book. At a meeting with Mongolian leaders, Andrews heard detailed descriptions of the creature, even though none of them had ever seen it themselves. One of them described it as looking like a sausage, about 2 feet long, with no head or legs. According to him, the worm was so venomous that just touching it could instantly take your life, and it lived in the loneliest parts of the Gobi Desert. Andrews didn't think the creature was real, but he shared these stories again in another book. In May 2005, 4 friends from Great Britain who search for monsters professionally decided to try their luck. They made drawings of the worm and hired local people to hand out flyers all over the Gobi Desert. These flyers offered a reward to anyone who could give information about the worm or even bring them a specimen. They thought loud sounds that other explorers tried would scare the beast away. Some told them it likes damp conditions, so they came up with a plan to block streams of water to create wet areas that would lure the worm out. Their plan didn't work because it was too hard to build dams in the desert. They ended up using small traps, but didn't find any actual proof that the worm existed. But they did meet locals who shared interesting stories about strange creatures they had seen over 70 years. Over the years, stories of the monster spread around the world. In some of them, it's only 1 foot long. In others, it's as large as a human. It's white-gray or scaly and brown, or maybe fleshy and bright red. Someone said it resembled a snake, or maybe a caterpillar, or maybe it has wings and can fly. And some believe it could be a supernatural evil being without a body. Maybe the stories are so different, and the search operations are so fruitless, because the creature doesn't even exist. Or it could be one of many cryptids. Those creatures like Bigfoot, Yeti, the Loch Ness Monster, their existence has yet to be proven. In 1983, one scientist who was visiting the region heard that an old man had managed to catch the mysterious worm. He also learned there was a nest nearby. The scientist bravely approached the hole in the sand and put his hand inside. A giant creature dragged him in, and he was never seen again. Just kidding. He actually found a Tartar sand boa inside. It's a chunky, burrowing, non-venomous snake that has small eyes and gray-brown scales. He showed it to the locals to verify if it was the monster, and supposedly all of them said yes. Most Mongolians who know about the worm still believe it's real. Now, even though people call our supposed monster a worm, it's just what it sounds like in the English translation. Many Mongol cultures have used this word for centuries to refer to any animals they thought to be really dangerous, especially snakes, even non-venomous ones. So, it doesn't have to be a literal worm after all. Worms are soft and squishy, but a creature living in the harsh Gobi Desert would need to be tougher, more like a snake or a type of lizard without legs. Neither of these creatures can shoot electricity or spit acid like they say the death worm does. But some snakes, like cobras, can spit venom that's dangerous for people. If it were real, the creature would have a backbone, and explorers searching for it would likely find some bones or evidence left behind. And there are actually fossil remains all over the Gobi Desert. Scientists found representatives of over 80 dino groups here over the last almost 100 years. It all started with the world's first dinosaur egg nests. This discovery changed all the scientists knew about dinos. It was the first proof they laid eggs. In the following 2 years, the same expedition team unearthed over 100 dinosaurs and took them to the American Museum of Natural History, where you can still see them today. Some of them were swimming around in the Cretaceous Sea that used to be here about 71 million years ago. They resembled modern birds. The mystery of the megaworm is still unsolved, but there used to be another mystery scientists finally managed to explain. Back in the 13th century, a famous traveler, Marco Polo, not the guy from the swimming pool game, crossed the Gobi Desert. He thought he could hear mysterious noises, like the sounds of musical instruments such as drums. He wrote about it in his book and believed he might be hearing the voices of restless spirits. Scientists call these noises singing sands or booming sands. Unlike the squeaky sound you might hear when walking on a sandy beach, these desert sounds are much louder, like a musical instrument playing deep, haunting notes. Over the years, people came up with all kinds of ideas about what caused the sounds, like underground water or winds making the sand vibrate. Not all dunes can do this, and scientists wanted to figure out why. Sometimes the winds might cause a small avalanche on the side of a dune, and then you can hear the magical sound start. But this is rare. So, to study it, scientists had to help the dunes sing. They climbed to the top of a dune and slid down on their backs, using their hands and feet to push sand down. As the sand tumbled, the sound started softly and got louder. They could even feel the vibrations with their hands. So, they found out that for a dune to sing, a few special things need to happen. The grains of sand must be the right shape, the dune has to be big, and the sand must be very dry, so no singing after it rains. Inside the dune, there's a hard layer of packed sand that acts like a giant speaker. This layer bounces the sound waves back and forth, makes the noise louder and louder, and creates a haunting melody that can fill the desert air. In other words, the dunes can play tunes. Yeah, sorry, I couldn't help myself with that one.
Today, I'm going to tell you about creatures that had unique features which allowed them to grow to incredible sizes. They were some of the most impressive animals to have ever existed on our planet. The Argentinosaurus is a genus of sauropod dinosaurs that lived approximately 97 million years ago in what is now South America. Scientists think it was one of the largest land animals ever, with a length of up to 100 feet and a weight of up to 100 tons. A farmer stumbled upon a giant leg bone while tending his cattle. That's how he discovered the first fossils of the Argentinosaurus in Argentina in 1987. Further excavations uncovered more bones, revealing a massive dinosaur that would have dwarfed most other animals of its time. The Spinosaurus, meaning spine lizard, is a genus of theropod dinosaur that lived around 97 million years ago in what is now North Africa. It is believed to be one of the largest carnivorous dinosaurs to ever exist, with a length of up to 60 feet and a weight of up to 23 tons. The Spinosaurus is known for its distinctive elongated sail-like structure on its back. It was likely used for thermoregulation. It also had long crocodile-like jaws that were lined with sharp teeth. This allowed the creature to catch and eat large prey, such as fish, crocodiles, and other dinosaurs. The first fossils of the Spinosaurus were discovered in Egypt in 1912. The sperm whale, Physeter macrocephalus, is a species of toothed whale that is the largest toothed predator on Earth. It also has the largest brain of any animal species. It is found in oceans all over the world and can dive to depths of up to 7,000 feet in search of food. You can easily recognize sperm whales by their massive, block-shaped heads, which can measure up to 1/3 of their total body length. They have dark brown or grayish-blue skin and a distinctive wrinkled appearance. The Titanoboa is an extinct genus of a giant snake that lived approximately 58 million years ago. It is considered to be the largest known snake ever. It could grow up to 42 feet and weighed around 2,500 pounds. The first fossils of the Titanoboa were discovered in a coal mine in Colombia in 2004. This discovery meant a lot because it provided insights into the size and behavior of snakes during the Paleocene era, as well as the overall climate and ecosystem of the time. The blue whale, Balænoptera musculus, is the largest animal on Earth, measuring up to 100 feet in length and weighing as much as 200 tons. These marine mammals are found in oceans all over the world and can live up to 90 years. Blue whales have a long, streamlined body that is usually blue-gray in color with mottled patterns. They have a small dorsal fin and 2 pectoral fins that are about 1/3 the length of their body. Blue whales feed on tiny shrimp-like creatures called krill, and they eat a lot. A single adult blue whale can eat up to 8,000 pounds of krill in a day. The Leadsichthus is an extinct genus of large, bony fish that lived during the Jurassic period, approximately 155 million years ago. It is believed to be one of the largest fish that have ever lived. Some estimates suggest that it could grow up to 55 feet in length. The first fossils of Leadsichthus were discovered in England in the 19th century, and more recent discoveries have been made in other parts of Europe, South America, and Africa. Despite its enormous size, the Leadsichthus was a filter feeder, similar to modern-day whale sharks, and likely fed on plankton and other small organisms. The creature did it by simply swimming with its enormous mouth open, filtering water through its gills. The pterodostro is an extinct species of flamingo-like birds that lived approximately 35 million years ago. They were relatively small birds with a wingspan of about 2-3 feet. And they were known for their distinctive long, narrow beaks equipped with comb-like structures used for filter feeding. The pterodostro lived in shallow bodies of water, like lakes and lagoons, and mostly fed on small crustaceans and other tiny organisms. The animal filtered them from the water using the comb-like structures on the inside of its beak while swimming through the water. The African elephant is the largest land animal on Earth and one of the most recognizable ones. There are 2 species of the African elephant, the savanna elephant, Loxodonta africana, and the forest elephant, Loxodonta cyclotis. You can see them in various parts of sub-Saharan Africa. These creatures can be identified by their large size, gray skin, and long trunks. African elephants can grow up to 13 feet tall and weigh up to 14,000 pounds, depending on the species and gender.
The legend goes that a dwarf named Fafnir was famous for his strength and courage. Because of his qualities, he was tasked with protecting their kingdom. Dwarves were known to gather a lot of wealth, so a bit of added security was a must. I mean, they lived in a house made from gold and precious gems. But Fafnir also had another special talent. He was able to shapeshift. Tricked by Loki, the Norse spirit of mischief, Fafnir was taken over by his greed and the shine of his father's treasure. He decided he did not want to share any of it, not even with his father or his brothers. He stole it and ran away all by himself to a place he'd be hard to find, the middle of the desert. To protect his wealth, Fafnir transformed into a huge dragon. His new appearance looked like a huge snake, powerful and scary. His magical powers did not end there, though. Because the dragon couldn't fly, he also spread poison all around his new home, so no one had a chance to survive if they wanted to take his gold away. Fafnir was soon defeated by a young hero named Sigurd. The legend of Fafnir tries to explain why family is more important than greed. It also shows the many magical powers dragons possess. But the most interesting part is that it's quite a good example of how dragons came to be in our tales. But hey, this is just one of the many stories mentioning dragons. Just switch on your TV or peek into any bookstore, and you'll surely stumble upon dragons somewhere. Variations of dragon-like creatures have been described in stories from all over the world, from Asia to Northern Europe. Most of these creatures are depicted with reptile-like bodies, wings, and claws. And the scariest trait of them all, they can breathe fire out of their mouths. The name of these creatures comes from the Latin word draconum, which translates to huge serpent. But let's take a trip down memory lane to see how it all started. An Asian historian, for example, discovered some fossils back in the 4th century BCE and decided that he'd stumbled upon dragons. It's easy to understand why he got so confused if you look at a fossilized stegosaurus. It was 30 feet long, 14 feet tall, and covered in armored plates and spikes. The Nile crocodile might have gotten mistaken for a dragon too. It still exists today and lives in sub-Saharan Africa. But it may have been more popular in ancient times. When reaching maturity, Nile crocodiles can grow up to 18 feet long. But that's not all. It can even walk with its body off the ground, and some were even pictured standing on their 2 back legs. Goannas are dragon-like lizards that live in Australia. Large as they are, they also have razor-sharp teeth and claws, and are also known to even produce venom. It's easy to see why goannas may be the source for the Australian version of dragons. When humans first discovered whale bones back in the day, we had no idea these animals lived in the sea. Given their size, we surely must have thought they were dangerous. And because we rarely see whales, if we don't go underwater of course, they were poorly understood and easily mistaken for dragons too. Probably the most interesting source of dragon mythology is actually the human brain. In a book called An Instinct for Dragons, there was a theory which claimed that dragons existed in almost all ancient cultures because we had evolved to fear large predators to survive. We aren't the only mammals to do this. Monkeys have an innate fear of snakes and large cats too, for example. When you combine these natural traits with folklore, you get a lot of dragon stories everywhere, adapted to each region. Reptilian beasts with magical powers date back as far as the origins of human civilization itself. I'm talking about ancient Mesopotamia. Humans back then used to believe in all sorts of creatures, but their head spirit was Marduk, the patron of the city of Babylon. If you look at the artwork from back then, Marduk was depicted with a snake-like dragon at his side. It could be either nice or vengeful, depending on what mood it was in. If you want to sign up to become a dragon, the first thing they'll ask you at the interview will be if you can breathe fire, of course. So scientists have tried to look into some ways that could make it real for dragons to breathe out fire without damaging their throats. To do that, they examined the bombardier beetle. This eccentric insect can pack up some really hot substances in its belly. Once the creature gets bothered by something, it shoots out a fiery load of chemicals. In all fairness, it's not really fire, but it does burn, so it's close enough. Going back to dragons, they'd need to have similar glands in their throats to produce the same effect. But where do dragons come from? They didn't just appear out of nowhere, regardless of the source you consult. Some tales, like that of Fafnir, say that even humans can turn into dragons. But the most popular theory is that dragons start out as eggs. Some sources even draft a series of stages a dragon has to go through during its life. Everything starts with hatching. Dragons are said to eat their way out of those shells and break the sides of the egg. Then there's the wormling stage, which is what dragon specialists, or dragonologists if you like, call a newly hatched dragon. It's still small and weak, but don't worry, it can take care of itself pretty well. The rest of a dragon's life stages are pretty self-explanatory. There are grown-up dragons, then ancient ones. A dragon's life ends when it reaches the twilight stage. Some sources claim dragons never stopped growing. Others even say they never reach the end of their lives. They just pass on to another type of spiritual existence. Dragons are known to be the symbol of a lot of different things. But that all depends on their origin. In some regions of Asia, they are known to bring luck, power, and wealth. To become a powerful warrior in Britain, you'd need to first defeat a dragon. That's why you often see them on flags. The flag of Wales, for example, has a large red dragon on a green and white background. Western stories aren't as nice to dragons. They are often seen as evil and vengeful. Another myth associated with dragons is that they love gold and precious stones. This greedy side of their temperament seems to date back to ancient Greece, where dragons were tasked with guarding treasures. Some of these guarding dragons were seen in such tales as The Hobbit and in the Harry Potter series. As for dragons' magical abilities, they also vary a lot. Some were said to have blood with supernatural properties. Some were rumored to be able to speak. Others were famous for their wisdom. A lot of dragons in ancient literature could fly or shapeshift, even into humans. Some real-life creatures got their names thanks to bearing a resemblance to dragons, like the dragonfly that has more than 5,000 subspecies we know about. It got its name from folklore tales, as Europeans in the Middle Ages saw it as an evil insect. Dragonflies were accused of some really nasty things, like biting people's eyes and mouths. But the creature that resembles mythical dragons most is a reptile called the flying dragon. They're seen in wooded areas of Southeast Asia. They don't really have wings per se, but parts of their ribs are elongated to support some extra skin that allows them to leap through the air between trees. Those wings are also brightly colored and contrast with their brown bodies.
Dinosaurs are some of the most fascinating creatures to have ever walked Earth. It's a shame that we won't be able to have Jurassic Park, where we can see some of the coolest creatures come to life. But we are actually living with some creatures that are just as old as dinosaurs, such as crocodiles and sharks. They haven't changed much since they appeared millions of years ago. But most dinos didn't make it when the asteroid struck Earth. In a way, the asteroid was a giant reset button for the planet. After hitting Earth, this space traveler wiped out almost every living thing. The sky was covered with ash, which blocked out sun rays. That meant that plants couldn't grow, and this made a lot of herbivores, really hungry. As a result, they had to change their diet and adapt to the new changes. This forced some of those dinosaurs to take on a new path in life, turning into some modern animals we know today. If the asteroid had changed its course just a bit, then dinosaurs would have remained the dominant species. So, what would have happened if dinosaurs had stuck around? Well, first of all, evolution would have played out differently for them. Maybe during those millions of years, humans would not have evolved to be on top of the food chain. Imagine a world where dinosaurs still existed today. If dinosaurs had evolved as humans did, then we'd have to compete with them. There were multiple species of humans, but Homo sapiens, also known as us, prevailed. A humanoid dino, or dinoid, would be something strange. First of all, they would look different, more reptilian than us. Our brain sizes would differ, and they would be physically bigger and stronger. Putting a human and a dinoid side by side would be interesting. First of all, dinoids would have scales as opposed to human skin, and their teeth would be sharper. They would probably not have 5 fingers on each hand, and their nails would be sharp claws. Also, we don't know what they would sound like, but they'd possibly be guttural like crocodiles. Dinosaurs had very good vision compared to mammals, so it's possible we'd see dinoids with large eyes. The population of Earth has reached a staggering 8 billion people, and we've changed our environment to suit our needs. With that said, if dinoids were the dominant creatures, then the environment would be suited for them. Speaking of physical features, scientists predicted what dinoids would look like if they had evolved into intelligent creatures that walked upright and had opposable thumbs. These wiggly thumbs are important for evolution, since they helped humans start using tools for defending themselves and hunting. The creature may not look like the ideal reptile, and its appearance might not be flattering. But if dinosaurs had evolved, then these creatures could be your classmate or colleague at work. Not all dinosaurs were alike, as their fossils have shown. Some were gigantic, while others resembled any modern-day animal. The biggest land-walking dinosaur was the titanosaur, although the measurements are only rough estimates based on fossilized bones. It's estimated that the dino was around 122 feet long and lived between 100 to 95 million years ago. It was so massive that its weight was equivalent to 18 modern-day elephants. There were dinosaurs all over the world in different time eras, climates, and landscapes. However, only a handful were known as giants. But though they excelled in body size, they lacked in brain size. Some of the most well-known dinosaurs, like the Allosaurus and Stegosaurus, had very small brains, like me, which means it would have been nearly impossible for them to properly evolve into intelligent beings. Tell me about it. But in the late Cretaceous period, the T-Rex roamed the land. It had larger brains than its Allosaurus counterparts, which were millions of years behind. Even so, the T-Rex's brain only weighed just under a pound. A human brain is nearly 3 pounds. It might have been cool to see a T-Rex evolve into an intelligent being with opposable thumbs on its tiny stick hands. Contrary to popular belief, the T-Rex was actually quite slow, and a human could have easily outrun it. So, we know that these days, they wouldn't belong in any competitive sports that involve running. We know that dinosaurs could be herbivores and carnivores. But throughout their evolution, one thing remained the same: they had small brains. Other forms of dinosaurs were around too, such as long-legged and horned dinosaurs. Either way, they were on top of the food chain even when little mammals had cameo appearances. We have to consider that when the asteroid struck and wiped out dinosaurs, mammals took over the scene. If dinosaurs and mammals had shared the dominant position in the food chain and had followed a similar path in their evolution, then today's reality would be completely different than what we have now. Dinosaurs would have bigger brains and would compete with humans for the title of the smartest creature. One of the reasons why humans and parrots can talk is because of the strength and shape of our tongues. The evolved dinosaurs would have a different skull, shaped to fit such a tongue if they wanted to talk like humans. One of the reasons why humans made it to where we are now is because we evolved to stand upright to detect predators. This was one challenge we had to overcome in order to survive. But what would dinosaurs need to challenge if they were already the most dominant creatures? Some of the big-brained dinosaurs had long legs, which means they could run fast, detect predators, and grab food that otherwise would be beyond their reach. Their evolutionary path would be very different from that of humans, and maybe even more advanced. Their brains could have evolved into something impressive. They could turn out smarter than us and possess quicker reflexes. Imagine dinosaurs discovering gravity instead of Isaac Newton, or a dinosaur writing plays and poems better than William Shakespeare. Imagine dinosaurs possessing the creative knowledge to produce some of the finest art in history. Music and cinema would revolve around dinosaur culture, and fashion would look otherworldly. We would live in peace with dinoids, but we would certainly compete with them. The World Cup would feature dinosaurs and humans playing for their national teams, but clubs would be exclusively human or dinosaur. Some professions would be dominated solely by one species, and more physically demanding jobs would be taken by dinosaurs, like laborers and security guards. Eventually, dinosaurs would take over the world since they would be physically stronger than humans and would have better advantages than us. Humans, on the other hand, would need to figure out a way to keep up with dinosaurs. Mammals had a different path of evolution, where they never became gigantic super beasts as dinosaurs did. Instead, their brains developed and grew big. But even though humans are the smartest creatures on the planet, we don't have the biggest brain. Animals like orcas, whales, elephants, and other apes have bigger brains here. So why are we smarter than them? The answer is, we don't know. The brain is the most complex organ we have, and we know so little about it. We don't even know exactly why it's so complex or why it behaves like that. Today's dinosaur descendants, like crows and parrots, have complex brains, which allows them to communicate, use tools, and even count. Bigger doesn't always mean better in this case. A parrot's brain is smaller than a cat's, but it's far more complex and intelligent than that of any feline out there. Some scientists argue that dinosaurs from the movies aren't 100% accurate, and that they used to have feathers. In terms of evolution, some small feathered dinos might have followed the path of primates. They might have evolved into a tree-dwelling primate that may also have followed the path of becoming another species of human. Now, you can't find living dinosaurs nowadays, which is a good thing, mostly, but you can still meet some creatures that might have gone to lunch with them. The frilled shark, for example, is a living fossil that comes from a family of sharks that have been around for about 80 million years. One of the coolest things about it is its long, eel-like body that can grow as long as 6 feet. It has 6 pairs of gills on its throat, which help the frilled shark breathe in the deep, cold ocean where there isn't much oxygen. The shark can move very quickly, like a snake, to catch its prey when it least expects it. Little frilled sharks take an exceptionally long time to grow, up to 3.5 years, which is one of the longest times for any animal with a backbone. The Chinese giant salamander is another living fossil that can tell you what was going on Earth around 170 million years ago. Now, when I say tell, I really mean it, as it can make sounds like hisses, whistles, and barks, and even a noise that sounds like a crying kid. The biggest Chinese salamander found so far weighed 130 pounds, as heavy as 2 Dalmatians, and was almost 6 feet long. Giant salamanders like to be alone. Hey, I want to be alone. And will chase away other salamanders from their space, except when it's time to start a family. During the day, they hide and sleep under rocks. They can make a special substance from their skin that keeps predators away. Now, gharials are reptiles that have been around for about 38 million years. They live in India and Nepal in slow-moving, muddy rivers. Sadly, there are very few gharials left in the wild, less than 100. These creatures can't control their body temperature, so they need to sunbathe to get warm or cool down in the water if they get too hot. Their eyes are close together and face forward, which helps them see in 3 dimensions and judge distances more accurately. Gharials also have a transparent third eyelid that protects their eyes when they're underwater. They have over 100 sharp teeth, but they can't chew their food. Instead, they use their strong jaws to grab prey and then, swallow it whole. The alligator gar is a fish that has a family history of more than 100 million years. It still has some cool features from ancient times, like being able to breathe both air and water. It also has a special spiral-shaped intestine, like a shark. The alligator gar is one of the biggest and heaviest fish in North America. Just like an alligator, it has a long body and snout, plus a row of sharp teeth. But instead of legs, the gar has fins to help it swim underwater. The tuatara isn't a lizard as you might think, and isn't a dinosaur either. This New Zealand resident is one of the most unique animals in the world. Scientists love studying tuataras because they can help us understand how today's lizards and snakes evolved. One of the coolest things about the tuatara is its third eye, called a parietal eye, on its head. It has its own lens, retina, and a nerve that connects it to the brain. Scientists think it might help the tuatara know when it's light or dark outside and absorb sunlight to make vitamin D or help them keep their body temperature exactly right. Tuataras can live an extraordinarily long time, up to 100 years. Cassowaries are the youngsters on our list, as they've been around for only 60 million years. They have some things in common with dinosaurs, like their 3-toed feet and how they breathe. Cassowaries love to eat fruit, lots and lots of fruit. This love of fruit helps the rainforest, because when cassowaries eat the fruit, their bodies don't harm the seeds inside. As they move around the forest, they spread these seeds, you can guess how, with their own natural fertilizer, helping new plants grow. Cassowaries are big birds, about 6 feet tall and weigh over 100 pounds. They have a special claw on each foot that is 5 inches long, and they can use it to kick real fast. If they feel threatened, they can charge, kick, and even jump on someone. They can also leap up to 5 feet in the air. So, the best thing to do is stay far, far away from where they live. The order Notostraca is a group of crustaceans that you may know as tadpole shrimp or shield shrimps. These animals have been around for about 360 million years. They have a wide, flat shell that covers their head, and they have a pair of eyes on top. These creatures can be found all over the world in different kinds of water, like freshwater, brackish water, and even salty pools. They can also look different depending on where they live. Notostracans aren't picky eaters and can snack on pretty much anything, from plants to small animals and other shrimps. Some of them are considered pests in places like California rice paddies because they stir up the mud, which blocks sunlight from reaching the young rice plants. Sturgeons are some of the largest fish species on the planet. They live only in the cool waters of the northern hemisphere and never travel below the equator. Even though they are huge, sturgeons don't have teeth. They eat by sucking food off the bottom of rivers, gulfs, lakes, and oceans. Scientists believe that sturgeons came from a group of fish that first appeared around 419 million years ago, long before dinosaurs even existed. Their ancestors survived a big extinction event that wiped out 90% of all species and went on to become the largest fish in many rivers in North America and Eurasia. Sturgeons can live up to 100 years old or even older. Female sturgeons can lay up to 3 million eggs at a time, but not all of the eggs eventually turn into real fish. Our next hero, the Pacific lamprey, has successfully lived through at least 4 mass extinctions. Its ancient ancestors evolved over 450 million years ago. These creatures have cartilage instead of bones and a third eye, which is a special light-sensing organ on top of their heads. Instead of a regular jaw, they have a mouth surrounded by teeth. They latch onto prey and sup up body fluids like real underwater vampires. And although he wasn't living underwater, the story goes that King Henry I of England might have lost his life because of a lamprey. The English monarch loved this fish so much that he defied doctors' orders to stop eating its flesh. He got sick every time he'd have it, but the lack of bones and the unusual taste made the royal fall in love with it. As a result, he got some scary symptoms from eating lamprey and eventually passed away. Can you say clueless? The elephant fish, also called the Australian ghost shark, has been on Earth for around 400 million years. Even though they're related to sharks, they aren't actually sharks. Instead of bones, their bodies are made entirely of cartilage. These fish have a special shiny tissue in their eyes that can make their eyes look like they change color from yellow to green. Elephant fish can be pretty tough and will fight back if they feel threatened. They like to be alone and usually don't hang out with other fish. Horseshoe crabs also deserve the title of survival champs, as they've been around even before dinosaurs, since 450 million years ago. 4 species are still roaming the ocean from Maine all the way to Mexico. Horseshoe crabs are more like spiders than ticks than they are like real crabs. They have 9 eyes, plus extra light sensors near their tails, so they can see really well. They breathe underwater using flap-like gills near their belly, and sometimes they use these gills to swim upside down. Every spring, when the tide is high, these creatures come up to the beach at night to mate and lay their eggs, and you can see hundreds of thousands of them. Hundreds of dinosaur species roamed our planet, and researchers give a name to a new type approximately every 2 weeks. It's not fair to stick to T-Rex, Stegosaurus, Spinosaurus, and other famous sauruses all the time. They've had their chance to shine in the movies and across the internet. So let's check out dinosaurs that no one talks about. First on our list is Torosaurus. The special thing about this dinosaur is that it definitely had one of the largest skulls ever found. It was big because of this frill going from the back of the animal's skull and covering its neck. The frill wasn't there for protection. It was probably just to show off a bit. The bone in the frill was thin and full of holes. As you can see, it's very similar to Triceratops. There are still debates about whether these two are the same species, but more and more studies show that they were more like cousins. They were probably similar in size, but Torosaurus had a longer head with big openings, as well as longer frill bones with a groove on top. It also had more pairs of horns on the back of the frill. Some like to call Torosaurus a bull lizard. These fellows were plant eaters that may have lived in social groups. They existed at approximately the same age, but Torosaurus somehow ended up on the less popular side of the family. Kentrosaurus was a small stegosaurus. It's one of the least cuddly dinosaurs of all time. Its long, thin spikes seemed to be a pretty good defense mechanism. Stegosaurus, on the other hand, had shorter, thicker spikes that were less likely to bend or snap when the animal used them. Now, you wouldn't want to get anywhere near Kentrosaurus, though. Its tail could swing in a big half circle and hit with a force strong enough to break a human skull. Any volunteers? No? Okay. One scientist used scans of the dino's fossils to make a computer model of its skeleton. The model showed that Kentrosaurus had a flexible neck. It must have been really useful for looking around to see if something interesting was going on or if there was any dangerous animals trying to sneak up. Kentrosaurus typically walked on all four legs with straight hind limbs. The computer model tells us it could spread its front legs out to its sides, too. Maybe it was a way to protect its belly during fights. Stegosauruses, in general, had tails that were like big weights at the back of their bodies. That's why their balance point was closer to their hips. That's also the reason why they could easily stand on their hind legs and swing their tails around. So most people haven't heard of heterodontosaurs, even though their fossils show that dinosaurs got feathers way back before we thought and in groups where we didn't expect it. In 2008, paleontologists identified the first known skull of a baby heterodontosaurus, which was less than 2 inches long, smaller than a tea bag. This baby dinosaur had relatively big eyes and a short snout compared to bigger ones of its kind. Now, what's really interesting is that some scientists used to think that Heterodontosaurus's tusks, like those of modern warthogs, only appeared when they were fully grown. But it seems they had them from the early stages of their life. Heterodontosaurs had 5 fingers on each hand, 2 of which were opposable. It was a good tool, considering the animal probably ate both plants and meat. Humans have different types of teeth, some for biting, some for chewing, and also canines. But most reptiles have just one kind of teeth. Heterodontosaurus was special because it had 3 different types of teeth: small peg-like ones, big teeth resembling canines, and square-shaped teeth that did the cutting job. Scientists are not entirely sure how this creature used these different types of teeth. Maybe it was for digging up roots, breaking into termite nests, or even defending themselves against dangerous animals. Okay, say this name with me now: Psittacosaurus. She was quite a common dinosaur in its time, but she never still gained popularity. Scientists found out that when these dinosaurs were young, they probably crawled, considering they had longer arms and short legs. But as they got older, between 4 and 6 years old, their hind legs started growing much faster and became much longer than their front legs. So, later in life, they likely didn't move on all 4s anymore, but walked on 2 legs. Inside the stomach of one of these creatures, scientists found pebbles. This shows the animals either had a hard time digesting what it ate, or it didn't chew its food very well. Its beak looks quite familiar. That's how it got its specific name, a parrot lizard. It was really strong, and some believe the creature used it to crack and open tough nuts and seeds before the pebbles in its stomach helped mash them up for digestion. These guys might have been good at swimming. They had broad feet, and the shape of their tail could have helped them move in the water relatively easily. Some scientists even believe they might have spent most of their life swimming in rivers and lakes. In 2004, researchers found something really sweet. 24 young parrot lizards huddled together. They were too big to be hatchlings, so it could be a bunch of teenagers who had left their nests and then formed a group where they could support one another and defend themselves better. But apparently, that plan didn't work out so well. Now, check this one out, Stygimoloch, or as they call it, Styx demon. We're looking at a peaceful plant-eating creature with bony spikes and knobs on its skull. Most scientists believe it was a younger form of this fellow, even though they used to think they were a separate species. Stygimoloch is smaller than its more popular cousin, but it's also more robust and has a pretty thick neck. This dinosaur, with small forelimbs and long hind legs 3 feet high, which is half as high as an average human. That doesn't sound dangerous in the world of giant and fierce dinosaurs, but the animal had a very thick skull roof. Maybe it wasn't the strongest tool to defend itself, but it probably helped in combat with rivals from its own species. They most likely headbutted to win the hearts of their chosen ones. But rivals from its own herd were a piece of cake compared to the predators that might have gone after it. After all, this dino lived at the same time as old T-Rex. Now, when someone tells you to picture a dinosaur, Chisaosaurus would probably be the last thing coming to your mind. It looks as if you've put together pieces of random animals and tried to make your friends believe this truly was a real animal that once roamed the earth. But it's actually a dino, with giant sharp claws on its forelimbs, a bulky body, and a long neck ending with a tiny head. Now, don't let the claws scare you though. These creatures didn't go after other animals since they were herbivores, but these claws could protect the animal from intruders and predators. The full scientific name of this creature describes it as a giant sloth-like reptile from China. This animal was one of the biggest and oldest members of the group where it belonged, which lived around 115 million years ago. No, I wasn't around then. At first, it was hard to tell which animals were related to this weird-looking dinosaur. But in the 1990s, scientists made a conclusion that they were modified plant-eating theropods, which is similar to carnivorous dinos. They also most likely had feathers and small wings, like some sort of a very big turkey. Now, thanks to new fossil discoveries and technologies, we're getting to learn more and more about the biology of dinosaurs. Some people don't need to know more than the fact that a few of them were colossal, terrifying, and vicious. But for those of us that do, the use of comparative biology, pigment analysis, and powerful new X-rays have allowed us to gain insight into specific features, such as their colors, eating behaviors, and the shapes of their tongues. Yes, that's right, the shapes of their tongues, which, for a long period of time, was something of a mystery. This is because soft, fleshy dinosaur parts are hardly ever retained in fossil form. But thanks to the discovery of some surviving hyoid bones, which are situated at the root of the tongue in front of the neck, we now have some insight. Most animals have this hyoid bone that anchors the tongue. The shape and complexity of the bone determine how free-moving the tongue can be. Scientists have discovered that nearly all dinosaurs had simple tongues that laid flat and were extremely similar to the tongues found inside the mouth of a crocodile today. Yeah, this crocodile. Go ahead and take a closer look. Nah, just kidding. Come on back. Let's take a look at some specific dinosaurs and start with the Brachiosaurus. Let me stick my neck out on the line by guessing that most of you will be familiar with this dinosaur because of its neck. You know, the one which was typically 30 feet in length. Despite its neck being its most distinctive feature, its name actually translates to arm lizard in Greek. It's common knowledge that the Brachiosaurus is one of the largest dinosaurs to ever have lived. On average, it reached 76 feet in length and 40 feet in height. That's roughly the length of 2 school buses and as high as a 4-story building. none of which were around in the era of the big guy here. Fragmentary leg bones and vertebra of even larger dinosaur species are known, but these skeletal remains are too incomplete to determine their exact size. So this guy may have been the largest dinosaur ever. A renowned herbivore, thank goodness. The Brachiosaurus is thought to have eaten up to 880 pounds of dry plant matter every day. Most of this was made up of coniferous trees, ginkgos, and cycads. This target might have been hard to hit for this dinosaur, as researchers have learned that its teeth were spoon-shaped and not ideal for chewing food. This means that the creature would have swallowed vegetation whole, as its teeth were suited to stripping it but not breaking up large chunks of plants. This, along with the dinosaur's body shape, suggests that the Brachiosaurus would have liked to feed as quickly as possible. Dinos like these didn't always make use of their ability to strip towering trees when dining. The Brachiosaurus traveled in herds, moving to the next location once they had exhausted all of the local vegetation. And I mean all of the local vegetation, not just that which hung high on trees. It's likely that the creatures supplemented their diets with vegetation at lower levels, especially after they'd done a number on all the nearby trees. This method of feasting was the most energetically appealing for this giant. By munching on lower vegetation, researchers believe that the dinosaurs saved up to 80% in energy compared to when foraging for high-up food sources. They have also discovered that the nostrils of a Brachiosaurus were on the front of its face and not the top. This is because we now know they roamed the fertile floodplains in their respective herds. For decades, it was believed that these creatures lived in deep, watery swamps. Let's look at another common misconception about a popular dinosaur. Please put your hands together for the Tyrannosaurus rex, which is arguably the most famous of all dinosaurs. Discoveries from the past 100 years have revealed that theropods had heavily feathered skin. Theropods are the family of dinosaurs to which the T-Rex belongs, so naturally, people began to think that the creature would have been covered in feathers as well. However, a study from 2017 took skin impressions from the iconic dinosaur and found no evidence of the structures required to support feathers. If a T-Rex did have feathers, they would have been limited to its back. Researchers accept that other large dinosaurs of the same family as the T-Rex have been discovered with their remains covered in feathers. An example of this would be the Yutyrannus dinosaur. But as of now, the accepted theory is that feathers weren't a common feature of T-Rexes. This makes it easier to believe that feathers were exclusive to smaller tyrannosaurids and were there as a means of keeping the creature warm. For a long period of time, researchers thought feathers were an exclusive feature of the theropod family. But this theory has been debunked. Just like the kid at camp who was kicked out of the top bunk. You know, debunked. Anyway, fossil evidence discovered in Siberia now suggests that multiple different family groups of dinosaurs had feathers. The Siberian fossils in question belong to another species of dinosaur, Calindrodromeus zebucolicus. Oh, you think I mispronounced that? Okay, prove it. Now, this dinosaur, I'll call her Calinda, had a pelvis structure superficially similar to that of a bird and was roughly 4.5 feet long, about as tall as a fridge. Since the purpose of feathers on dinosaurs was for warmth, it's quite possible that dinosaurs from cold weather climates had more feathers than their counterparts in warm weather climates. In general, bigger animals struggle less with keeping themselves cool, so it's likely that any of the large dinosaurs who lived in these warm climates had no feathers at all. Smaller dinosaurs who lived in cold climates, on the contrary, had plenty of feathers. We now even understand what some of the designs and patterns of these feathers on dinosaurs looked like, thanks to the discovery of an ornithomimus, complete with feather and skin impressions. The name of this dinosaur is derived from Greek and actually translates to bird mimic. They were typically 11.5 feet in length, nearly as tall as a giraffe, and despite being omnivorous, had no teeth. Its other distinctive features include 3 fingers, which were all unusually the same size and length. And despite their thin boned skulls, they also had large brain cavities. Their legs were extremely long, in particular their foot bones. Combine this with their toothless beaks and long necks, and yep, it must have looked a lot like an ostrich. Although they're not as big as the Brachiosaurus or dinosaurs in general, they are bigger than any other bird in the world. And it wasn't just the body limbs of an ornithomimus that made it resemble an ostrich. They also had very similar feather patterns. Their heads, necks, and lower legs were mostly bare of feathers, but the rest of their bodies were well coated in downy plumage. This is what you call a bird's layer of feathers as a whole. It's possible, like an ostrich, that the dinosaur would have used this unusual feather pattern to regulate its body temperature. Despite some dinosaurs possessing feathers like birds, on top of also being their distant relatives, dinosaurs didn't have the type of feathers required to fly for most of their existence. Feathers found in fossil impressions or preserved in amber have allowed researchers to gain insight into why these creatures weren't very aerodynamic. The structure of these feathers appears to be very simple, with a poorly defined and flexible central shaft. These feathers would have better served any dinosaur as a fashion statement, as they would have helped attract the attention of other dinosaurs. These feathers also would have had the ability to regulate body temperature. Surprised to hear that dinosaurs had ostrich-like feathers? Wait till I tell you that their prehistoric distant reptile cousins had something that looked like fur. Allow me to introduce you to the pterosaur. Its name is derived from Greek and translates to winged lizard. Just like dinosaurs, they were initially thought to have scaly or leathery skin all over their bodies. But over the course of the 20th century, fossil examinations revealed that many parts of a pterosaur's body were furry. The wingspan of a pterosaur could reach the length of over 23 feet, about as long as a London bus. Its toothless jaw was very long and resembled that of a pelican. How could something that looks like a pelican be so terrifying? These creatures were coated in pycnofibers. Those were simple structures, feather-like in composition, but strand-like and fuzzy like fur. Further research suggests that some parts of the pterosaur's body had more complex kinds of feathers with branching strands. If this is accurate, it would be the first time feathers were found on an animal that was neither a dinosaur nor a bird.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dinos' bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocus or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050? Antarctica wasn't always a frozen wasteland. A long time ago, it was full of life, and 56 million years ago, something terrifying stalked its jungles. A giant, flesh-eating bird. It was around 6 feet tall and weighed as much as a lion. For millions of years, nothing could challenge it. So why did it disappear? And could there be even bigger predators still hidden beneath the ice? Paleontologists found 2 massive claw bones in Antarctica, sharp, curved, and powerful, belonging to this bird. They were dug up from the Epresian-aged rocks of Seymour Island, which means they're around 40 to 50 million years old. Their shape left no doubt. These were the so-called terror birds. Their scientific name is Forus rauceti, some of the most fearsome predators to ever walk the earth. They were flightless and didn't even need wings. Instead, they could sprint at breakneck speeds, like ostriches from a nightmare. For millions of years, these birds ruled South America. But now, for the first time, their presence has been confirmed in Antarctica. No surprise here. Back then, South America and Antarctica were still connected, allowing animals to easily commute between continents. So these birds probably migrated south to adapt to life on Antarctica's prehistoric landmass. It didn't just survive here, it thrived. But at some point, this nightmare of an animal vanished. Why? Most likely because of the temperature changes. Antarctica was cooling, slowly turning into the frozen wasteland we know today. Its prey may have declined, leaving the predator without enough food. Eventually, it disappeared, leaving no descendants behind. Researchers hope that they'll find a complete skeleton eventually. They're also wondering where there might be even bigger species waiting to be discovered. Perhaps these birds evolved into a completely new Antarctic lineage. But for now, all we have are 2 giant, creepy claws. People often think that there are almost no animals or plants in Antarctica. But that's not true at all. Penguins waddle around, and forget the cute tiny ones. Antarctica used to have 6-foot-tall monsters. The emperor penguins are the largest penguin species alive today. They can dive over 1,800 feet deep and hold their breath for over 20 minutes. There were giant ancient penguins around 38 million years ago. They were the size of humans. Fossils show they had long, sharp beaks, making them terrifying hunters of fish and squid. The fish there are also absolutely fascinating. Forget giant squids. Colossal squids are nightmares even bigger. Some reach over 40 feet long with massive, super sharp beaks and eyes the size of dinner plates. Finally, orcas, the apex predators of the Antarctic Ocean. They hunt in packs, working together like a wolf pack of the sea to take down seals, fish, and even massive whales. There are even tiny plants like moss and algae. Antarctic hairgrass and pearlwort. They somehow survive against all odds. There are many other myths going on about Antarctica. For example, some people think that when icebergs break off from glaciers, they immediately start drifting straight into the open ocean until they melt. But the reality is way more chaotic. First, when an iceberg breaks off from a glacier or ice shelf, it has to deal with underwater obstacles. It can stay stuck on the seafloor for decades without moving. Then they get caught in powerful whirlpools and spin in place for months. One iceberg, a 23A, spent nearly 40 years frozen in place before finally breaking free, only to get caught in a swirling ocean vortex for another 8 months. After that, their paths are influenced by ocean currents, tides, winds, and even underwater topography. They don't just float freely, their movements are full of literal, unexpected twists. And speaking of glaciers, another strange rumor is that some humans can't travel more than 311 miles inland in Antarctica because of an impassable ice wall, freezing jet fuel, deadly winds, and no oxygen. But this is completely false. Antarctica has been explored by planes, vehicles, and even scientists on foot. There's an entire research station sitting at the South Pole. People live there all year long. The ice wall is real, a massive ice cliff rising above the ocean. But that isn't some secret barrier, it's an ice shelf. These are thick slabs of ice that form when glaciers slowly flow off the land and spread over the ocean. Almost 3/4 of Antarctica's coastline is made up of them, but they don't form some giant ring around the world. Antarctica is one of the most extreme places on Earth, but we've conquered its challenges, and we keep learning more about it every year. That's why every year, millions of dollars are poured into keeping research stations running, protecting wildlife, and making sure the people who live there have everything they need. But where does all this money go? Well, Antarctica stations are basically small cities. There's electricity, heating, water purification, food storage, and medical facilities. The biggest station, McMurdo, is basically a town with over 1,000 people in summer. It has everything from a fire station to a gym. The South Pole Station is super deep inland, so it's one of the hardest places to supply. Getting food and fuel there requires airplanes flying thousands of miles in extreme cold. But the internet loves a good mystery. When Google Maps revealed what looked like a massive doorway in Antarctica, conspiracy theorists went wild. People joked about everything from Bigfoot's vacation home to a secret base, or even a Star Trek spaceship hangar hidden in the ice. But there's a way simpler and less exciting explanation. It's actually a grounded iceberg, a chunk of ice that got stuck in shallow water and is now slowly melting. As ice moves across the landscape, it flows around bumps and obstacles, creating odd shapes. The process of melting, breaking apart, and refreezing can carve ice into unexpected forms. Antarctica also has incredibly strong downward-blowing winds that sculpt ice into dramatic formations over time. No secret doorway, unfortunately. And speaking of doors, for years, Ushuaia, Argentina, has been called the gateway to Antarctica. The last stop before the icy continent. The place where expeditions begin. But there's another option. Punta Arenas, Chile. Let's compare them. Ushuaia is closer to Antarctica. It's the top departure point for tourists going on cruises. But no regular flights to Antarctica. No major scientific bases operating from here. It's basically controlled by the military, which refuses to allow private flights, only commercially operated ships. Yes, Punta Arenas is further from Antarctica, but 22 countries and global organizations use it as their main base. There are regular flights to Antarctica happening there every year. Private airlines can actually operate here, making it the real air connection to Antarctica. Ushuaia may have the best location physically, but Punta Arenas actually runs the show. Argentina made a huge error in picking its Antarctic airbase. Instead of setting up a simple, accessible base at sea level, they built Marambio Base, very high, on rough terrain, completely impossible to reach by land. Everything has to be flown in by helicopter, making operations slow, expensive, and frustrating. For 50 years, Argentina stubbornly stuck to this bad decision, while Chile set up efficient, well-planned bases that the world now uses. If things don't change, Ushuaia will be nothing more than a tourist stop. But what's terrifying is that Antarctica seems to be returning to its past. It's supposed to be the coldest place on Earth, but something shocking happened just recently. For the first time in recorded history, temperatures in Antarctica broke 68 degrees Fahrenheit. This continent is buried under miles of ice. Usually, temperatures there can drop to minus 112 degrees. But in the winter of 2020, scientists recorded an insane 69 degrees on Seymour Island, hotter than many places in Europe at that time. Scientists believe there are several reasons for that. First, there are changes in the way heat moves around the planet's waters. Second, melting permafrost due to the planet warming. It looks like the climate is changing faster than expected.
It was a 40 feet long and 12 feet tall beast, the king of dinosaurs. Its massive and muscular body weighed up to 8 tons. Its serrated teeth were sharp, and its jaws had a bite so strong they could crush a car. The creature had 2 powerful legs. It lived in forested river valleys all across North America, almost 70 million years ago. I'm talking about the most famous movie star among dinosaurs, T-Rex. It was very smart, with a brain twice as big as that of any large meat-eating dino. It was slower than other hunters, developing a speed of up to 12 miles per hour. Its other weakness was its small arms. Some scientists think they were just an evolutionary leftover, like the pelvic bones of some snakes. But others believe T-Rex used its arms to hunt. Its 4-inch claws helped the animal out. T-Rex was undoubtedly frightening, but surprisingly, there were even scarier dinosaurs in the past. Around 100 million years ago, there was a giant creature with the name that meant a spine lizard. It was Spinosaurus, the largest carnivorous dino. It was bigger than T-Rex and could grow almost 60 feet long. Its weight could be as great as 22 tons. The animal had long spines on its back. They could grow up to 7 feet long and were connected by folds of skin. They formed something that looked like a sail. Some scientists think it was a hump Spinosaurus used to store water. This dino had dense bones and short hind limbs. Researchers believe that these dinos could use their flat and wide-clawed feet for paddling. This was the first dino that could ever swim. Unfortunately, it couldn't process smells like most other theropods. These were a group of 2-legged carnivorous dinosaurs that appeared on Earth 230 million years ago. That's why the animals the creature hunted could hide from it on land. The Spino dino spent most of its time in the water. It roamed the swamps of North Africa and mostly fed on fish, big prehistoric sharks, and sometimes other dinosaurs. It had a long, thin, and narrow snout like a crocodile. Unlike other dinos of its kind, which had curved teeth, Spinosaurus had conically shaped straight teeth. Giganotosaurus, which is the Greek word for giant southern lizard, was considered the largest meat-eating dino until Spinosaurus was found. It lived around 100 million years ago in South America, around 30 million years before T-Rex appeared there. It was longer and taller, but more slender than T-Rex. And while T-Rex had 2 fingers, this giant had 3. It walked upright on its 2 big and very strong legs. Its tail was pointed and thin, which helped the creature make fast turns while running and keep its balance. The animal could move at a speed of up to 31 miles per hour. T-Rex's maximum speed was 25 miles per hour at the most. Any faster than that, and the giant could lose its balance and fall over. Giganotosaurus had 2 arms with sharp claws. It was mostly an opportunistic meat eater feeding on everything it found on its way. Its bite wasn't as strong as T-Rex's, but it still managed to deal with some bigger animals, like herbivore dinosaurs. Maybe there was even an Argentinosaurus among them, the biggest animals ever found. It's hard to imagine how Giganotosaurus could take down a 50-ton beast on its own. That's why scientists think they may have hunted in groups. The animal's only weakness was its small brain. It was twice smaller than T-Rex's. This means the T could at least win a chess game. Big retractable sickle-shaped claws in the creature's feet are great for cutting. Ladies and gentlemen, welcome Utahraptor. That's a mini T-Rex that lived 125 million years ago. If a big T-Rex was coming for you, you could hide under a rock or some other place where it wouldn't be able to reach you. But there would be no place where its mini version couldn't follow you. Discovered in Utah, strong, toothy, and armored with huge claws, more than 9 inches long, an adult Utahraptor was 20 feet long and 5 feet tall at the hip. These creatures were covered in feathers. This is why fully grown animals look like gigantic turkeys. The Utahraptor's main weakness was their size. They were a bit smaller than many other dinos, but these guys made up for that by hunting in packs. Allosaurus, which means a different lizard in Greek, was a massive carnivore reaching 40 feet in length and weighing 2 tons. It roamed the Earth around 150 million years ago. Similar to T-Rex, this dino had strong back legs and a large snout. Its mouth was full of sharp teeth. The animal easily lost them when eating, but they usually grew back. Allosaurus was already fully grown by the age of 15, and its lifespan was around 28 years. The creature had a short neck and a long, narrow skull, disproportionately big compared to the rest of its body. This dino also had a pair of horns above its eyes and ridges along the top of its nasal bones leading to those horns. Allosaurus chased big herbivore dinosaurs. When several Allosauruses gathered in a group, they could take down even such colossal creatures as Apatosaurus. But scientists still doubt if they could cooperate, because these dinos were generally not too friendly toward one another. Some of the animal's bones had an hourglass shape, which made them lighter and reduced their strength. They were similar to the hollow bones modern birds have. Another weakness of this dino was its bite. It was less powerful than that of some modern animals, like lions, alligators, or leopards. Scientists think Allosaurus may have used its skull as a hatchet. The Rhizinosaurus was one of the freakiest dinos out there. It lived 100 to 60 million years ago. It had a very small head and bizarre feet with 4 toes, unlike their ancestors that had 3. Its body was covered with feathers. This weirdo had the longest claws scientists have ever recorded. They were 3 feet long each. These claws were curved and sharp. The dino used them to collect plants for lunch. Scientists are still not sure if this creature was a herbivore or carnivore, or both. The dino had a long neck. There were no teeth in its upper jaw. Its wrist bones were like the ones modern birds have. The Rhizinosaurus might have evolved from a meat-eating to plant-eating animal throughout time. Unfortunately, in comparison with meat-eaters, herbivore dinosaurs were much weaker, and still, those claws could make its enemies think twice. High-spined lizard, or a Crocanthosaurus, lived 110 million years ago. It was 2 feet shorter than T-Rex but had a similar body structure. Like T-Rex's, these creatures often went after bigger and more challenging animals. For example, with those backbones so hard, it seemed as if they were carrying a giant turtle shell, like Ankylosaur. The high-spined lizard was very territorial. It had a brain shaped like the letter S and an excellent sense of smell. What made a Crocanthosaurus vulnerable was its small arms. And still, the creature used them to hunt other animals surprisingly well. The dino pulled its catch close to its torso, which was like a hug you wouldn't be able to escape from. Diplodocus lived 150 million years ago. The 90-foot-long creature was possibly the longest dinosaur ever. Its tail, which could reach 46 feet in length, was the longest tail of any animal ever. And its neck was more than 20 feet long. The underside of the dino's tail had 2 rows of bones, which made the creature even stronger and more mobile. Diplodocus didn't look scary, long-necked, gentle, peacefully munching on plants, until it used its tail like a whip, making even the scariest meat-eaters back away. This tail was the center of the dino's mass, which was why Diplodocus could move very quickly. Scientists first thought, this is a lizard-like animal. but its posture was more like that of an elephant. Plus, Diplodocus had nasal openings on its forehead. The dino's weakness was its small teeth and weak force bite. Quetzalcoatlus was the biggest flying animal ever. It lived 70 million years ago and controlled the skies of North America. It was a toothy, pin-headed creature with a blunt snout. It was as tall as a giraffe and weighed 550 pounds. Quetzalcoatlus had a small torso and long neck and legs. Its wings were short compared to the rest of its body, but still long enough to stretch for 40 feet. Scientists think this animal could fly at a speed of up to 80 miles per hour and travel 400 miles in a day. This dino was weaker than, let's say, T-Rex or most other carnivores of that time, but it had powerful muscles, which helped the animal rise into the air in the blink of an eye.
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash, 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much later came the iPhone. So your starship is flying through space at 99.9% of the speed of light. Hey, aren't you cool? The stars turn into bright, continuous lines. Infinite outer space has shrunk into a tunnel. A bright flash ahead. Boom! Starship shoots out of the tunnel like a cork. You see the ancient Earth. The computer says you went back 70 million years. You're a paleontologist of the future who traveled through time for one purpose – to see with your own eyes the most underappreciated dinosaur in history. You have come down to Earth and are walking through the jungle. Suddenly, you hear a mighty roar. There's a dinosaur coming out of the trees. It's more than twice your height and weighs as much as 4 cars. Scientists have found only 2 huge arms left of this dino. For 60 years, Deinocheirus has been a major mystery in paleontology. Now we can see this creature in its entirety. They managed to find a complete set of fossils in Mongolia. Translated from Latin, the name of this dinosaur means terrible hand. Apparently, this dino was lousy at playing poker. Deinocheirus is an animal cocktail that nature has prepared to make you both shriek and laugh. Let's take a look at it from the point of view of the evolution itself. First, we take the T-Rex. Deinocheirus and the king of the dinosaurs are about the same size. From the T-Rex, we'll only leave the powerful hind legs and the long tail. Instead of small forelimbs, we'll attach mighty 8-feet-long arms. And let's not forget about the fingers with razor-sharp claws. Each claw is as long as a kitchen knife. Then we add a hump like a camel's, a neck like an ostrich's, and a horse's head. And instead of a toothy mouth, we put a duckbill. Now our Deinocheirus is ready. It also has long and sharp claws on its flat feet. Such broad soles help it walk along the river bottom and not sink into the silt. Most scientists believe it was covered in feathers too. Plants were the main dish on this dinosaur's menu. To digest plant food, Deinocheirus swallowed stones. Many modern birds do the same. Stones in the stomach grind the tough plant fibers. In one of the Deinocheiruses, scientists found 1,400 of those. Yes, this dino had a huge belly, which slowed it down a lot. With such a size, Deinocheirus lived for a very long time, 75 to 300 years, give or take. In a 100-million-year-old piece of amber, they found strange bones. They belong to the smallest dinosaur known to science. Take 2 paper bills from your wallet. This dino weighed the same. It was about the size of a modern hummingbird. Scientists don't know what the tiny dinosaur looked like more, a lizard or a bird, but they're pretty sure it could fly and hunted insects. Over 100 sharp teeth confirm that. What happens when you cross a chicken and a crocodile? You get one of these bad guys, a Hesperonychus. This dinosaur was small but had quite an attitude. It lived in North America and probably hunted mammals. It weighed only 4 pounds and was covered in feathers like a chicken. If the sloth was a dinosaur, it would look like a Suzhou lizard. It moved on 2 legs, was as tall as a modern giraffe, but weighed 3 times as much. Suzhou lizard had feathers on its body, and a long neck helped it look in all directions. Overall, the tail of this dinosaur made it look like a giant rat on 2 legs. When scientists first saw the fossils of this animal, they didn't believe they were real. The Hulscoraptor looks like a hybrid of a velociraptor and an ostrich, only this dino was the size of a goose. The creature's strong hind limbs confirmed that it could walk on land. The dinosaur hunted fish, diving underwater for its prey. Now, we're used to flying animals having 2 wings, but evolution loves to break the rules. The Microraptor had 4 wings. Strong feathers were attached to each of those. The dinosaur weighed no more than 2 pounds. Its feathers were black and shiny like a crow's. There are no birds on the planet that have 4 wings. That means they evolved from 2-winged dinosaurs. Microraptor was the dead-end branch of evolution that didn't give way to any new species of animals. It seems that this hard-to-pronounce guy, I'll give it a shot, Tanystrophus, was a dinosaur drawn for a cartoon. But it existed in reality and lived in the water. It weighed 300 pounds and was 20 feet long. Half of its body was a flexible neck the size of a green anaconda. Scientists don't know why the creature had such a long neck. Most likely the dinosaur used it to catch fish or play jump rope. Imagine that 66 million years ago, I wasn't around then, an asteroid didn't crash into our planet. The dinosaurs didn't disappear, and the mammals failed to dominate the Earth. This means the primates didn't evolve and remained in the trees. Who would have taken the place of primates in such a world? Many scientists believe it could be Troodon. The dinosaur had the largest brain relative to body size. It walked on 2 legs and was about the size of a human. Hypothetically, Troodon could evolve and become as intelligent as we humans are now. By the way, the smallest brain relative to body size belongs to Stegosaurus. It was the largest of the armored dinos. It was a plant eater, but its powerful tail and sharp spikes were feared by all hunters of the age. A Stegosaurus weighed almost 4 tons, but its brain was meh, not much larger than a hot dog. Pagomastax was no bigger than a domestic cat, and it ran wild and free in Africa 100 to 200 million years ago. Imagine a bipedal lizard that looks like a parrot. Pegomastax was covered both with feathers and porcupine-like quills. It had a beak, but 2 sharp fangs grew from the lower jaw. Still, the creature's scary appearance is deceiving. The dino ran fast and could bite hard, but it was a peaceful plant eater all the same. Now, this one, Lenhenicus, lived 80 million years ago. It resembled an ostrich that weighed like a medium-sized parrot. It could run quickly and hunted insects. Instead of arms, this dinosaur grew 2 tiny fingers with claws on their ends. It's the only one-fingered dinosaur known to science. This strange creature was one of the ancestors of modern birds. Jeholopterus was a flying dinosaur, looking as if it came straight from a sci-fi movie. It looked like a cat with bat wings. The creature was feeding on insects, but there's another theory that it could feed like a mosquito. This dino landed on the backs of large dinosaurs and pierced their thick skin with sharp fangs. Now, this is a fairy tale unicorn. It's as white as snow, beautiful and graceful. And this is a Qingdao lizard, the real-life prototype of that horned horse. A bony horn more than 15 inches long grew on its head. Perhaps the horn helped float in the water, attract partners, or make different sounds. The fairy tale unicorn is definitely cuter than this prehistoric creature. Our next guy, Inostrancevia, resembled a cross between a lizard and a tiger. Imagine an animal that weighs as much as 5 wild boars, with the body length of a sedan. Limbs with sharp claws, fangs similar to those of a saber-toothed tiger, and powerful jaws. It was one of the most dangerous animals that roamed the planet Earth. It occupied a niche that today belongs to lions, tigers, and other large cats. Next, please. Epidexeturus. Now, this is a small dinosaur about the size of a pigeon. It couldn't fly, but it was one of the first dinos with feathers. They were different from those of modern birds, though. They weren't divided into separate threads, but were whole and resembled plant leaves. This big guy, Therizinosaurus, isn't only known for its strange appearance and size, although it was as tall as a 5-story building and weighed like an elephant. The giant was notorious for the largest claws on the planet. It was really a manicurist's nightmare. 2-inch-long scythes protruded from its fingers. Despite those horrific appendages, it ate plant food, chewing it with its small teeth. The humongous jaws were needed to pull leaves off of tall trees. Ouch! Hey, I'm growing here! Meet the largest animal that flew in the earthly sky, Quetzalcoatlus. Just imagine a creature with a wingspan almost the width of a basketball court. To lift such a machine, it needed to be lightweight, so it only weighed as much as a modern pig, with its wings looking like a thin membrane. They stretched from the bottom of the legs to the elongated fingers. Artists often depict this creature covered in feathers, but its body was actually coated with fibers similar to human and animal hair. Acrotholus is an unusual dinosaur that wore a cap made of hard bone. No, not a baseball cap. The creature was the size of a Labrador retriever dog, but not as friendly. It wouldn't run after a stick. Rather, it would rush and ram its hard head into the rival of the same species or a predator. They ruled the planet for over 170 million years and then disappeared. History says it was a huge city-sized asteroid that came from space and hit the land of the Yucatan Peninsula around 66 million years ago. It caused terrible environmental changes, debris in the air blocking the sunlight so the plants couldn't survive. Temperatures on Earth's surface plunged. The animals were struggling to survive until they finally went extinct. At least, that's something many paleontologists believe happened. Now, they found out dinosaurs were about to go extinct even before the asteroid. Their diversity started to go down 10 million years before the asteroid. Older, long-living species didn't evolve enough to adapt to all changes in the environment, such as higher sea levels, massive volcanic activity, cooler periods. Dinosaurs preferred a warm climate because it helped them to keep a stable body temperature. Dinosaurs lived on all 7 continents, even in Antarctica. That's because it wasn't all ice back then. Around 90 million years ago, Antarctica was a swampy rainforest with a warm, pleasant climate. It was even in a different location, only 560 miles from the then South Pole. That was the time of the warmest climate on our planet. The sea level was 560 feet higher than today, and the tropical sea surface could reach temperatures up to 95 degrees. Antarctica still had something like polar night, months without sunlight, but the climate around the South Pole was mild and temperate, with no ice masses. Dinosaurs didn't shed their skin in one long piece like today's reptiles do. Scientists believe they shed it in small pieces, had something like dinosaur fur. There was a dinosaur, Pegomastax, that looked like a cross between a porcupine and a parrot. It had 1-inch long jaws and ate plants. It had a short beak and self-sharpening long teeth. They were like scissors this small dinosaur used to slice up plants. Our modern lion has a mighty bite, but a big and scary T-Rex bites more than 2 times stronger. The king of the dinosaurs has the strongest bite amongst all land animals, 3.5 times stronger than today's record holder, the Australian saltwater crocodile. It also had the longest teeth, almost 10 inches long, the length of an iPad. Most modern animals are either warm-blooded or cold-blooded. Dinosaurs were somewhere in between. Scientists think they mainly were mesotherms, which means the activity of their muscles could warm their bodies, but their body temperature could fluctuate too. Many dinosaurs, such as Triceratops and Stegosaurus, had spikes, plates, horns, crests, or other bizarre structures on their bodies. In the beginning, scientists thought that's for things like defense. They had neither sharp teeth nor hooked claws on the toes to hunt. But soon, they expanded the theory. It was probably a way to impress their mates and identify members of their kind. One species, namely Pachycephalosaurus, even had a funky bone hat on top of its head. Scary, tall as buildings, massive. That's what we saw in the movies, but dinosaurs mainly were human-sized or even smaller. Bigger bones were easy to be fossilized, so that's why we mostly find gigantic species. Eoraptor, or dawn stealer, was the first named dinosaur. Small and toothy, like me, it got its name because it comes from the dawn of the dinosaur age, the size of a German shepherd, but probably not that friendly. Arched back, sharp bony plates, curved tail. Ankylosaurus were some sort of giant, much-spikier dinosaur version of an armadillo. Its weak spot was a soft underbelly, but meat-eating dinos that were after this one had to flip that guy first to get there. Still, it was really tough because of their impressive gear. Scientists believe they even had bony eyelids. Some dinos ate meat, others plants, and some of them could nibble even on pebbles. One dinosaur, called Gallimimus, couldn't physically chew all those plants it ate, so it would ingest pebbles to mash up the food. Gallimimus looked like some weird alien mix of dinosaur and bird. But it couldn't dribble a basketball because its wrists weren't capable of keeping the palms parallel to the floor. And they had no three-point shot. The largest dinos were plant eaters. Meat eaters, or so-called theropods, were mostly smaller. One reason is that plant-eating dinosaurs were very greedy. They would devour enormous amounts of food, sometimes even swallowing the entire branches without chewing. Some of the biggest could eat a ton of food every day, like a bus-sized pile. There were also more plant-eating dinosaurs than the other ones. Scientists are still not sure if meat-eating dinosaurs were able to coordinate themselves in hunting groups. They were probably unfriendly towards each other, especially when it comes to sharing prey. Fossils, and the shape of delicate bones in the eye, tell dinosaurs mostly roamed around during the day. Scientists think only smaller meat-eating dinos, like Velociraptor, were active during the night. They were after those small mammals snuffling around and trying to find food, while big dinosaurs were asleep, or that's what they thought. Those small mammals were usually burrowing animals that survived both dinosaur reign and ice age hiding underground. Not all mammals were hiding from dinosaurs. Some small but sneaky creatures, like Repenomamus, would steal the eggs from big dinosaurs, which was a big thing considering they had to trick the mama dinosaur first. Researchers believe dinos tried to flap on the ground to get faster at running up inclined terrains to catch their prey. Such behavior caused them to learn how to fly, which of course happened through thousands of years. Dinosaurs were fuzzy and fluffy. They are related to birds, but even those early dino species that didn't fly had feathers, like gigantic, scary, fuzzy T-Rex. Movies lied. You just can't stand still and expect a T-Rex would pass you by. Its vision was probably better than one today's raptors have. Even without it, they still had a pretty good sense of smell. Running could help it though. Scientists calculate T-Rex could probably run at 12 miles per hour. It would shatter its bones at a greater speed. Some dinos had tails more than 45 feet long. Tails helped them to keep their balance when running, especially those that walked on two legs. Velociraptors were not like raptors we see on the screen, but more like some sort of prehistoric chickens. Small, a little bit bigger than a turkey, 2 feet in height, probably had feathers, hollow bones just like birds, mostly loners. But they were probably among the smartest dinos. Their brain was big compared to their bodies. They were as intelligent as today's ostriches. The name Velociraptor means speedy thief. Stegosaurus had a pretty big body, spiky plates, and a tiny brain, the size of a walnut or lime. But at least it had its own air conditioner. Researchers found out its spikes were filled with veins that transferred blood and developed a theory that they were cooling its giant body that way. Dimorphodon was the flying reptile with a wingspan of 8 feet and multi-purpose teeth. Teeth in the upper jaw were longer, sharper, and better for catching food from the water. The teeth in the bottom jaw were better for holding the game in transit. One of the first potential dinosaur discoveries was in China 3,500 years ago. No one knew about dinosaurs then, so people thought teeth they found could belong to dragons. The Hadrosaurus was a duck-billed dino with more than 1,000 teeth. When they would fall off, it could grow new ones indefinitely. Dinosaurs' eggs were pretty big, some as big as beach balls. Now that's an omelet. The Baryonyx was a big fan of fish. Its name means a heavy claw, and it got it because of big extended claws that were pretty sharp and made up the thumb of each hand. When catching fish, they used the claws like spears. Mosasaurus, also popular in movies, was not quite the dinosaur but a marine lizard, closely related to monitor lizards and snakes. Like a snake, it had jaws that could expand when swallowing the food. These creatures were speedy. They had a tail fin and flipper-like paddles instead of arms and legs. Researchers believe they had a weak sense of smell and poor perception of depth, so they had to develop a unique hunting technique